record here. So I think Mr. Akim can help us out with that.
Then some of us will be able to install all those things, but it remain. You said we should run it. We don't know how to run it, so that it will show now.
Yeah, I'm going to show us. I'm going to show us. Don't worry.
Okay, sir.
All right. So, as I was saying, so these are just the things that we'll be going through. So, for a start, I want us to all go to our Anaconda Navigator. For me, on my end, I already have my Jupyter Notebook opened here. So, but what we can just do on our systems now is we go to our Windows and then we type Anaconda. So we open Anaconda. So once we do that, we then launch the Jupyter Notebook program that is inside our Anaconda. It's going to take a while to load and it should bring us here. So let's all do that so that we are able to follow. Are we together?
Yes, sir.
All right. So once you launch the Jupyter Notebook, it should bring you. It's going to open your browser. Don't worry, you don't have any problem with it, because I'm going to explain why Jupyter Notebook is like that. Also, I think I should even open my Anaconda. Although it's going to take a while, but so I can explain certain things that we have inside and how we can leverage the softwares that are inside.
Which of the when I type Anaconda, it brought me Anaconda Navigator. Another it I have Anaconda Prompt, Anaconda SES, Anaconda PowerShell Prompt, Anaconda and Open Run as Administrator, Open File Location. I don't know which are the one.
So you have to open this one that has this green circle logo. Can you see my screen?
This application have an Anaconda Navigator app.
Exactly, yes. The Anaconda Navigator app itself is what you should open.
Okay.
All right. Are we all following? So if we are lagging, let's all talk so we are on the same page. So while our Anaconda Navigator is loading, and then it should bring us here. So I would just want to explain what we have here and what we can leverage from what we have inside Anaconda Navigator. So Anaconda Navigator itself is how do I call it, like a software that has softwares inside. So you have a lot of softwares. Now the advantage is that you don't have to install each of these softwares one by one. You can literally just install Anaconda Navigator and all of them come into one package. Now, from the name Anaconda, it's kind of related to snake, which is also related to Python, which is snake family kind of thing. So we might get the idea of where the name is coming from. And it has different softwares. So the first one is data law. So data law itself is an online data analysis tool. So it means that if you want to run online data analysis, you need a tool that you can use. You can use data law. And data law works with the assistant of JetBrains. So a JetBrains, so it uses a Python notebook, which is cloud-based. So just like, okay, so as we want to run Python for data analysis now, we can use data law for it. Do we understand that part? So that's one of the tools. Now, there's also IBM Mountain Studio Cloud. This also is used for analysis and visualization of data. So if you want to run analysis, you also want to do machine learning, training, and modeling, you can use the IBM Studio Cloud. Another thing you can use is Jupyter Lab. So Jupyter Lab is...
Sorry, good morning, sir.
Yeah, good morning.
Good morning, sir.
I can hear you.
Yeah,
good
so
morning.
sorry. I downloaded Mini Anaconda.
Yeah, so for Mini Anaconda, it's not going to bring you to this place. I'm going to explain how you would open your own Jupyter Notebook from Mini Anaconda.
Okay.
All right, but you can just follow us as I explain. So
Okay,
Jupyter Lab is also another package which is based on Jupyter Notebook, which is it's also used for like interactive and what's it called, reproductive computing. It's basically close to Jupyter Notebook. The only difference is just how they work, like in terms of the structure, like the look. The next thing we have is Jupyter Notebook. Jupyter Notebook is a web-based interactive environment. So literally, you can use it to run like human readable documents for which describes while describing the data analysis. So one of the things you can do with Jupyter Notebook is, because it is web-based, like I explained the other time, when you run Jupyter Notebook, so we can launch it now. While it is loading, we can just follow what I'm explaining, so we don't have to like waste time when we launch. So you can just click the launch for Jupyter Notebook. It's going to use, like I said, it's going to open up our web browser. So if the web browser is opened, it's not going to, there's no problem with that. It's just going to create a new tab on your window, on the browser itself. So as I was explaining, it's a web-based what's it called, notebook environment itself. So it uses the web structure in running Python programs for data analysis. It's not limited to data analysis. That's one of the things that we should also note. All of these tools are not just limited to data analysis. Anything you can do on Python, anything you can use Python for, you can literally use all of these softwares for it. It's just that majority of them are are specific in terms of what they use. Now the next thing is PowerShell prompt. PowerShell prompt runs exactly just like our our CMD, our command prompt, but this time around it's a terminal. So it works literally, it's just a terminal basically where you can run commands. So the next one we have is the Qt console. It's a Python Qt GUI, which is used for graphical graphical workflow. Also, you just run like Python codes on it. Now, same thing goes for Spider, but in terms of Spider is specifically for scientific Python development. So if you are running, you want to write codes that are scientific related in terms of what you are doing, Spider is something you can use. You can also use Spider to like run analysis code. There's no limitation to that also, like I said. Now, the other part is VS Code. This Visual Studio Code. Now, Visual Studio Code is another tool on its own that you can use to run multiple code lines. So you use it for so if you are running you want to write codes in various languages, for instance, you can use VS Code for it. So VS Code is not limited to only Python. It's for all of the languages. It's more like it's a notebook editor itself. So you can and you can also use it to connect. You can connect it to like other platforms. You also can use it to install packages that you want to run on your local, like on your laptop itself. So VS Code is that robust. Now, another thing we have here is BlueVix. BlueVix is a visualization tool, which is just used to explore relationship between databases. Another one we have is Orange. Another one we have is PyCharm, and then we have RStudio. Now, Orange and PyCharm are Python-based framework also. Now, for RStudio itself is built on a different language itself, which is R. So there's a programming language called R. Now, our programming language in its own form is specifically used for statistical and it's used for analysis, basically, not just statistical analysis, just analysis basically. So but this time around the language is different from Python. It's R. It has its own syntax, it has its own structure, and it has its own keywords. So it's very different from Python, but not very different, because it's more like focused into analysis compared to Python, that is quite robust and can be used for like anything. So basically, this Anaconda Navigator itself gives us that opportunity to have various softwares inside it. So we don't really have to start installing one after the other. From here, I can literally just install R if I want. I can install PyCharm if I want by just clicking install, and then it's just going to do everything I want for me automatically. Now, like I said the other time, we can just click on launch from here, and Jupyter Notebook would boot and open. And that way we can open Jupyter Notebook is by literally just searching Jupyter, and then we have Jupyter Notebook here. So it's not compulsory that whenever you want to open Jupyter Notebook, you have to first open Anaconda Navigator and then launch Jupyter Notebook. Once you've installed Anaconda Navigator and your Jupyter Notebook is also installed, automatically you can open your Jupyter Notebook without opening Anaconda Navigator. That way you don't have to, you save time, because for each of the softwares that you run, it takes time to load before opening. So that way you can run faster. And so lastly is when you have your Anaconda Navigator running, just to confirm, do we all have our Jupyter Notebook opened now to this kind of view? Are we together?
Yes, we're together.
Yes.
Do we have our
Yes.
Jupyter Notebook open here? Okay. So
Yes.
So now I'll just one of the things that we've noticed on our desktop, on our computer, is this 1 minute. So one of the things that we see on our computer is that there is this new icon, this Jupyter Notebook logo that is opened on our taskbar. Can we see it? Are we together?
No, I can't find it on my own.
Okay, all right, no problem. There is no problem if you can't find it on your own. It's literally just well, I'll explain how we can do that later. So another way, like I was explaining, how we can launch Jupyter Notebook, apart from opening from Anaconda Navigator or literally searching Jupyter Notebook on our search bar, we can, after searching Jupyter Notebook, you can just you can right click, and then you have pin to start taskbar here. So when you pin to taskbar here, it's going to literally just pin it to this taskbar, and then with just a click, you can open Jupyter Notebook. You can do that later on after the class, so you're able to like test run how it works. So you don't have to like click it twice or all of that. Just with one click, it launches. It takes a while also, but it's pretty much faster than searching or going through an Anaconda Navigator. So 1 minute, please. So now, while we are here, what do we see? We see something that looks um, like our file explorer, where you are able to see everything on your system. So you're able to see your desktop, your documents, your download, each of them as a folder. That's like your C drive or your D drive, depending on the drive you have on your system. Now, what we want to do is we want to look at what we have. So for instance, if you click on Anaconda 3, by just clicking on it, it takes you inside the Anaconda 3 folder, and you're able to see everything you have inside the folder. Do we get it? So if you need to go back, all you just need to do is click this link folder. It takes you back to the previous one. Same thing if you want to explore your document, for instance, by just clicking your document, you're able to see everything inside your document, and then you can literally just go back. So now, this is like I explained, it's just like our file explorer. So it means that whatever we can do on our file explorer, we can do it here. And the thing is, because it is connected, anything you do here automatically affects what is inside your file explorer, and anything you do in your file explorer automatically shows here. So it is connected to what you have inside your system. So now, literally, your Jupyter Notebook is more like what you have here is more like your file explorer in basic terms. So what we want to do now is we want to go into our we want to go to our desktop. We want to see where we sorry.
Hello, sir.
Yeah, I'm with you.
Yes, I think some of us are struggling to hear you because I posted on the chat that I could not hear you clearly, and some other person said it's breaking. I don't know if it's network or from only our side. So you're not that audible, please. If you can get closer to the system so that we can hear you loud and clear.
How is it now?
Okay. A little better.
Okay, all right, no problem. I think I will just speak up.
Hello, sir.
Yeah, hello, I can hear you.
Yeah. When I pin my Jupyter Notebook on my trash bar and open the Jupyter Notebook, it's not giving me the same thing that it gave you. It gave me a kind of a place where, like the place where we have to write, where I loaded
It took you to the command prompt part.
yes, to the command prompt.
Okay, so I think what you did was wrong. You opened your Anaconda prompt instead of your Jupyter Notebook. So what you're supposed to do is what you should just do is open your Anaconda Navigator and click on launch. This launch here, just click on it. So once you click on it, it's going to take you to your browser immediately.
Okay, this launch.
Yes.
Okay, sir. Okay, I will do.
All right. Okay.
Okay, I'm true, sir.
Okay, all right. So now, So as I was explaining, we want to now create a folder. So the folder itself, what it will do is we want to create a folder for this class for Python, or even if we have a folder for the whole training itself, we can literally go inside it and create a new folder and call it like Python for data analysis class. So that's what we want to do. So what we'll do now is we click on desktop if we have our folder on our desktop. I don't want us to go through the normal way of coming to the file explorer here and clicking new folder and all of that. We are going to see that what we do here would automatically show on our desktop if we have one. So I don't have any folder for this class previously, so I will just create a folder and then I will call it Python for data analysis. So we can also do that. So what you do is you click on new, Now under new you have Python 3, you have text file, you have folder, you have terminal. Now depending on what you want to create, what we want to create is a folder, right? So we click on folder and what's our folder? So we have it here on what's it called? Untitled folder. So now we want to name this folder. So we click on it and we say, like this. So our untitled folder, where's this folder? Okay, yeah. We click on it and we scroll up. We see rename at the top here. We see move, we see delete. So we click on rename. So we want to call this folder Python. I hope you can hear me clearly. Python for data analysis class. And then rename. Now, once you do this, if you come here, this is Python for data analysis. There is nothing here, right? So now, by the 5 parts we have here, we have desktop, and then we have Python for data analysis folder. These are folders. So I want to cross-check if what I've done is showing on my system. When I come to my file explorer, under desktop, I should have Python for data analysis. It's not here, right? So I can just refresh. So when I refresh, I have Python for data analysis class here now. And this was created 10:40 December 9, 2020, which is like 2 minutes ago. So when you open this, there is literally nothing inside. So now this is just to show us what we can do from Jupyter Notebook itself and how it is connected to our system. Any question before we move into the next?
Yes, sir. You've not explained how to open the mini Anaconda.
Okay, so for mini Anaconda, after installing, you've installed mini Anaconda, right? And you've done pip install, pandas, numpy, and all of that. Am I right?
Yes.
Okay, so
Install just me or all user?
what did you say?
It's saying like install for, is it I'll click on just me or for all users?
How many users do you have in your system?
Just me.
You can use just me.
Then destination folder.
Where do you want to install it? You can put it on your C drive.
C drive.
So let me explain what you have. Now, when you go to Anaconda prompt, what you have is your C drive, your user, then your what's it called, your system name itself. Now, just the way you have, so this is, for instance, this is your system. This is how your system is. You have a C drive, and you have can you hear me?
Yes, I can.
Okay, so you have your C drive, you have your E drive, which is your DVD drive, or your VCD, whichever one you have on your system. Then you have all of the folders that you have. Now, inside your C drive is divided into different parts. There is the part that holds the operating system on your system. There's the part that holds the accounts you have on your system, the users on your system. So when you open your user, you have two, depending on the number of users you have. If you have multiple users, you are going to have the number of users you have plus one. Plus one means the public is the additional one that you have. So inside this del, which is your own account, you have all of this in it. And that's why the other time when we opened Jupyter Notebook, what we actually saw was this part. This was the part we saw, like, how do I explain this guy? So this part that we have 3D object and Anaconda tree, all of those things is what we have here. Do we get it? So we have 3D object, Anaconda, contacts, desktop.
I'll do that.
So that's just the file path you can follow. So you can just literally just install that on your user here, and that should work. So once you are done, you can just run Jupyter and it should work literally. So now we've created our folder inside our desktop. So we have Python for data analysis class here. Now the next thing we want to do is we want to we don't have any data set here, but before we even come to
Excuse me, please.
Yeah, Muti.
Yeah, on that browser, my own folders, all the folders listed, I didn't see desktop there. I only saw documents and download.
You didn't see desktop, then it means
Yes.
that on your system itself, your inside your C drive, your desktop is not inside your C drive. It's probably somewhere else.
Okay, I'll check that.
All right, yeah. Like I explained the other time, what we have here, we'll come back again. What we have here, where we have desktop documents, downloads, everything, is literally what we have inside what we have in our C drive, the user, and the accounts that we are using. So it's possible that on your system you have multiple accounts. So if you have multiple accounts, your desktop might probably be sitting on that account. So you can see we have 3D objects, Anaconda, contacts. All of what we have here, all of what we have here is what we have here. And it's directly connected to our desktop itself, like the desktop on your system. So let's continue from there. Now, okay. So now what we want to do now is we want to run Python. Now, like we explained the other time, we can just come to new again, and inside this new we have Python 3. So all you just have to do is click Python 3, and then it's going to open a new so we have a new tab here. Now you see that we have two tabs now. The tab where we have where we're coming from, and the new tab that we have. Now this new tab itself is a Python file. That's why you see at the top here we have the Python 3 logo here. Are we getting it?
Yes.
All right. So another thing I would have here is let me just explain now. You see that automatically the file that we have here, which is untitled, is already here, untitled. It's now sitting inside our Python for data analysis class. And when I come to my file explorer also, see that we already have it here, untitled. And now it automatically creates a new checkpoint file, a new checkpoint folder that holds what is inside, what is running on Jupyter Notebook itself. Now, one of the things you see here is that it says Jupyter source file. This means that this file itself is coming from a Jupyter Notebook, like a Jupyter source itself, because there is Jupyter Notebook, there's Jupyter Lab. Don't let us forget that. So now it's coming from a Jupyter source file. and it's of Python. But we'll come back to other things later. So now let's continue from here. Now the extension that comes with it is ipynb. Now I just want to explain something to us so we don't mix up two things. Now what we have here is the extension is .ipynb, which means interactive Python notebook. So .ipynb means interactive Python notebook. Now this is a little bit different from .py, which is .python for a Python file. So let me see if I have like a Python file on my system. I'm coming 1 minute. Okay, yes. So I have this Python source file here. Now, when we look at this file itself, when we look at it in terms of its extension, you would see that it is .py, right? So the type of file is Python source file, which is .py. So it means that this is a Python file itself. Now, meanwhile, when we look at this Jupyter source file that I have here, when I go to the property, we see Jupyter source file .pynb. So now these two are not very different. The only difference is just that the source of each of the files are different. One of them is a Jupyter file. The other one is it's the exact Python file. Now, does it mean that they cannot run together? They can 100% run together because this is a Python code also. It's just that it is written in Jupyter, while this Python code itself is written in the source Python file, like source Python code itself. It doesn't have any issue. It's just that we just have to know the extensions, because by the time we start running some things and we try to open the Python file itself on another software like Visual Studio Code itself, we might see certain differences, and these differences are things that we should know. So now, one of the things that we want to do first is I want to change this. I want to call this Python class, or we can just call it anything. So let's just say P4DA. So my P4DA means Python for data analysis. So now, when I change this here, when I come here, you see that it has changed. So all of these do not require us to like refresh. Whatever we do automatically changes on all of the fonts that we have it. So if I come here, so we have P4DA also here. So it automatically just refreshes itself. But situation could occur where what you've done has not affected. All you just have to do is refresh, and that's all. There's no issue. Now, let's now go to what we have here on our task bar. The first thing we have is our file. Now, what does file do? File is just like the menu bar where you have what exactly you have in your file, what we want to do, like what we are doing on this page itself. So if you want to create a new notebook, you can literally just create one here. If you want to open, you can make copy, you can save as, you can rename, you can save and checkpoint, you can revert. Then you can also change the extensions that you have your file in. So for instance, I've written my codes and I want all of my codes to be exported as a PDF file. I can just click PDF via LaTeX and then it should work, but it's not going to work automatically except you have the LaTeX library running on your system. So that's when it's going to change that. Now, also here you would see now that you can literally change your NB extension to a Python extension because they are literally the same. And also you can have your codes, the codes you've written in Python here, you can have them in what's it called, in a PDF form. For some of us who are quite familiar with like LinkedIn or all of these social media platforms, you would sometimes see people write codes in Jupyter Notebook and then they export them in PDF files and they are able to like upload them for people to see. These are just the extensions that they literally just use in changing. I want to see if I have something around this. just to show us how it looks like. 1 minute. I can't. Okay. It takes a while. Okay, let's continue while this one is still loading. So the next thing we have is edit. Now, edit here we have cut cell, copy cell. So each of these what's it called? Each of these cells I have, each of these lines that I have are called cells because each code runs in a cell. Unlike Python, where whenever you run a code, it's going to run from the beginning. But in Jupyter Notebook, each of the codes that you run in each of the cells. So it means that I can have a code here, let's say 1 + 1. I can have another code here, 2 times 2 raised to power 2. And they are not going to run together. Whatever cell I run would be the one that would run, literally. So that's why you have all of these cells. Now I can cut this cell. So when I click cut cell, you see it's cut, and I can literally just paste the cell above or below, or I can paste the cell and replace whichever cell I am on. So when I do that now, automatically it removes the previous one. And so let me just go back, edit, undo. Okay, so these are just some of the things we can do here. Now another thing is you can delete cell, and you can also split cell. So if you want, let's say you've written certain codes, multiple codes in one cell, and you want to split them, you can split the cells. Also, you can merge cells above or below. So you want to merge all of the cells that are above together. So for instance, I'm on this cell and I want to merge the cell above. So when I do that, it merges the 2 cells together. These are 2 separate cells before, but now they are merged together. When I want to separate, once I am on the cell, I can click edit and split cell automatically. Now splitting on function is supposed to split in that way around. Oops, 1 minute. Edit, make cell above. Not supposed to do that. So the next thing that we have is I can move cell up and down. So I have this cell at the top. This cell at the top. If I want to move it down, I can just come and click cell down, it moves it down. Another way you can do that is using all of these shortcuts. So when I want to move this up, I can literally just do that here. So the next thing you have is you can do find and replace if you have like a large chunk of code and you want to just replace something. And so the next thing we have is view. Now for view, what we have for view is literally us being able to see what we have in each of the cells itself. So we can see a cell as the metadata, we can see it as a slideshow and all of that. So the next thing we want to is we want to insert cells above or below. So let's say, for instance, I'm writing some lines of code and I want to create a new cell at the top. Because when I run each of the cells, it goes to the next cell if there is a cell there. If there is no cell there, it creates a new cell. But if I want to create a new cell in between the first one and the second one, all I just have to do is insert cell below or insert cell above. So let me show what I mean. So let's say I have my name is Mutado in this cell, and I have this operation in this cell. Now, if I want to insert a cell under my name is Mutado, all I just have to do is insert cell below. It comes here because I was already on Mutado before, like this Mutado cell, and then I click cell below. Now, if I'm on this cell, this Mutado cell again, and I want to put a cell above it, all I just have to do is insert cell above, and then it creates a new cell at the top automatically. Now, the next thing I have is cell. Now, each of the cells themselves, what are the operations we can have in them? You can run cell. So it means if you have a code here and you want to run it, when you come to cell, you can just run and then it gives you an output. Now I'm going to explain what happens here, but don't bother yourself about why it is showing 2 when you have 2 raised to power 2 and 1 plus 1. I'm going to explain that later on. So now the other thing we can have is run cell and select below, run cell and insert below. We can have run all cells, so we have all codes and we want to run everything together. Now we can also have cell types. So cell types here shows the different types of things we can have inside a cell. For instance, you can have a cell that holds code, like we have here. You can have a cell that holds markdown. Markdowns are like let me see. Oops, okay, it's not showing here. So markdowns are like how do I explain? Like a comment, but this time around it is explaining what you have. It's not really a comment per se. It's just like a guide to explain that. I'm going to show us what a markdown is later on. Then the other one is raw notebook converts, which is just literally just raw text itself. Now, next thing we have is current output and all outputs. How we want the current output to look like, and how we want all of our outputs to look like. How we want all of our outputs to look like. Sorry, I can hear myself. So the next thing we have is kernel. A kernel is this whole operation itself, like this whole Python file. Sometimes you might be having challenges and you want to restart your Python, maybe because it is already lagging, it's hanging or something. So you can interrupt if there's a code, like an heavy code that is running and is affecting, it's taking so much to stop. You can restart, you can clear out, you can restart and clear output, you can restart and run all of your codes all over again. And you can also change kernel, but the only kernel we have here is Python 3. So we cannot really change Python 3 from Python 3, like it's just literally the same thing. Then the next thing we have is widgets. Widgets just basically save widget state, clear, download. Most times I really don't use this because we are not really needing all of this. The next thing we have is help. This help are documentation files or extensions where whenever you have any challenge you can go to and you can literally seek help from, because not even sometimes, yeah, let me just say sometimes, or as time goes on, as you are coding, you would face challenges and then you need a reference to go to. A reference with all of these references are places where you are able to get guides from. So when you click, for instance, pandas reference, it takes you to a pandas documentation file and you are able to see what is inside pandas. So if you have any challenge, for instance, you need an API, if you are running codes, or you need even a guide to tell you, okay, this is how you use pandas. You can literally just come here and you can come to like the user guide and it tells you all of what you need to do. So if you need, for instance, you want to merge what's it called? You want to merge data frames together. How do you merge them? So you have codes that explain how you do that here for you. So I would like to state that one of the things that you'd be doing as a developer or as a programmer is you have to learn how to read documentation files, because these are the files that would explain the problem that you have for you and how you solve them. Or whenever you have any problem, you can literally go to, and there are hundreds of documentations already done, like guides to help out. So if you want to reshape or pivot a file, a table, for instance, how do you do all of that? These are all of the functions that pandas itself has. We are going to come to pandas later on. So, but this is just one of it and how we can do that. So yeah, so this is what we have in terms of the menu bar and what we will be working with. Now, in terms of the shortcuts that we have here, the first one is save, this other one is new cell. If you want to add cell below, instead of using all of these menu bars. If you want to cut a cell, you want to copy a cell, you want to paste a cell, you want to move up and down, you want to run. So as I have, for instance, let me just comment this out. If I want to run this cell, instead of coming to cell run here, I can just literally click run here and it would work. Now, one of the things that we should also take note of are shortcuts. Like for instance, you see the shortcut here, Control Enter. So it means if I come here and I run want to comment this out again. Let me just say 2 times 3, and I press Shift Enter. Now you see that I did not move my cursor, I did not move my mouse, but then I run the code. That's because the mouse was already on this cell, and I just pressed Shift Enter, and then it runs the cell for me.
Hello, sir.
So yeah,
Hello, sir. What is the effect of this symbol of that you should put at the front of 2 multiplied by 2?
okay, yeah, that's a comment. I'm going to explain that once we get into the functions and the operators that we can use in Python. I'm just using this to explain the cells that we have. I'm going to move into that very soon. So this is to interrupt the kernel. So let's say I have a code that is running like a loop that is not ending. I can literally just click on this stop button. If I want to restart, I can use this. If I want to restart kernel and the whole notebook itself, I can use this. Now, if I want to change my cell, what's it called, output, like I have here, like the cell type, the code, markdown, raw notebook function, I can literally do that from this cell here. So I can have code, markdown, and all of that. So I don't really need to like use this when I know all of that. Now, this other part that we have here, the open command palette, this format, all of these things, I'm not sure we have that on our end. Yet we don't need to have it because these are just additional functionalities that I have on my own Jupyter Notebook that I'm literally just using in order to like make my work fine. Sorry. So all of these are just to like help me in terms of the codes that I write personally. It's not just it's not something very, very special like that. So now let me clear it.
So is it okay we have it too?
Yes, but it's a very I can't even remember how I did it self. Except I probably just go back and check or play around with certain things and remember how I did this. But I think it should probably be around leveraging ChatGPT or some bots with Jupyter Notebook. I think so. So I want to so I want to delete all of these cells, so I'm able to explain later what we have. So now let's now talk about Python itself, like the programming language itself. So now Python is a programming language, and from the word programming language, it is used to create things, to program, to it's a set of commands basically that tells something what to do and how to do it. Although the how comes in terms of algorithms, like a process, the process at which or the steps at which something is done. But then there are also ways at which we implement those algorithms in Python. But we don't have to bother ourselves with algorithms. We just have to like talk about the programming language itself and how it works. Now, the first thing that we want to know is, let's not forget, we have like an outlook here. From what we have in our syllabus, we've undo this installation part. Now, what we now want to discuss is the basic syntax and the data types in Python. Now, what is a syntax? So a syntax is the structure at which a language is written. So for instance, like I'm speaking English, in the syntax of English, the literal structure is noun, verb, and noun, verb, verbal noun. For instance, the boy ate rice. The boy is noun, verb is eat, rice noun. So that's like the old structure at which it comes and all of it. So now that's the simplest structure of a sentence in English language. Same thing for Python. The simplest structure is to have a variable or a value and a function an operator that comes with it, depending on how we want to have it. Now we are still going to get to that part. The next thing we want to have is data type. Now, the word data type itself it comes from the type of data that we have. Now, the type of data, what exactly is data? So a data is anything that we hold in terms of the language, anything. So the data can then have different data types. It could be a number, it could be a character, it could be a string, it could be floats or decimal. All of those things then comes under data type. So we'll explain some of those things. Now, then lastly is a variable. So a variable is a storage location. So I would give a variable to be like a name, basically, that holds something. So for instance, when we have an animal, each animal has a name that we are able to use to identify it. So that's exactly what a variable also is. Just like humans, we have name that we use to identify ourselves. So let's now go deeper into each of these. Like I said the other time, for a Python code to work fine, it has to be correct in terms of its syntax. If it's not correct in terms of its syntax, it's not going to work. So if I have something like this, 1 plus, and I run it, it gives an error. And then what is the error it gives? It gives syntax error. The syntax error now says what? Invalid syntax. So invalid syntax means that this structure is not correct. For instance, like I gave in English, if I said the boy ate, it's correct. Or I say Mortadel slept, it's correct in terms of its structure. But in Python, structures like this are not correct because it expects that there is a value or there is a number that comes after this, or there is a variable, something that you can reference that should come after what you have in terms of the operator. But this is syntactically wrong in Python. But if I have something like +1 and I run it, it gives 1. So this means that syntactically +1 is correct, but 1 plus is not correct in Python. So now let's now explain some of the syntax that we have and what we have under them. Now, the first thing we have under syntax, or for us to understand syntax, is to understand what we have called operators. What are operators? Operators are symbols or signs that we use to carry out certain functions. For instance, we have the plus sign. So this plus sign is used to carry out addition, simple mathematics that we know. But here also we need to identify certain differences that comes with what we already know in our pure maths. So the next one we have is the minus sign. So the minus sign is for subtraction. Are we following?
Yes, sir.
Yes.
Okay. So the next thing we have is the multiplication sign. So this multiplication sign is the star sign that we have on our 8. So if you want to get this sign, all you need to press is Shift 8. You will get this star sign. So this is the multiplication sign in Python. In terms of division, we have this sign, the forward slash. Forward slash is division. Now, the next one we have is the percentage sign. The percentage sign is called modulus. Now, modulus is the remainder of something, the remainder of a division. That's what is called modulus, the remainder of a division. For instance, if I say 2 divided by 1, the answer is 2 remainder 0, right? So if I come here and I say, for instance, 2 percentage 1, I should have 0, right? Because 2 divided by 1 is 2 remainder 0. Now, let me now come and say 1 percentage 2. 1 percentage 2 basically means 1 divided by 2. And 1 divided by 2 is what? Mathematically, what is 1 divided by 2?
Half.
Half. But we cannot have half because, like we said in modulus, modulus is the integer remainder of a division. So 1 divided by 2 is 1, because in what's it called, mathematically 1 divided by 2 is 0 remainder 1 mathematically. So that's why we have 1 divided by 2 to be 1 here. So let me just take us deeper a little bit. So let's say,
why not 0.5?
Yes, like I said, modulus is the integer remainder of a division. Do we get it? It is the remainder of the division, not so it doesn't come in decimal. It's an integer. Now, these functions or this operator would come in handy when we are working with certain divisions in the later things that we'll be doing in Python. But we just need to know this. But let me explain better now. For instance, what is 5 divided by 2 in mathematics?
0.5.
5 divided by 2 is not 0.5, sir. We don't want decimal. We don't want any points. We don't want to have any points. So it's 5 divided by 2 is 2 remainder 1. Am I correct?
Yes.
Yes. So when I run 5%2, what should be my answer?
The answer will be 1.
The answer should be 1. Exactly. The answer is 1. Now, okay.
So in a nutshell, Python does not recognize 0.5. It will just make it 1.
No, Python recognizes 0.5, but the operator we are using, don't forget, the operator we are using is the reason why we have this number. So let me show you something. So we have 5 divided by 2. It gives us 2.5. So Python identifies decimal, but the operator that is being used defines the output that you will get.
Oh.
Do we get
Okay.
it? Now, let me
Okay,
make
so
it,
that's what I meant to say. Okay. Go ahead.
so let me make it easier. For instance, if I have 5 divided by 3, if I want my answer in decimal, the answer should be 1.666666. Am I correct? Yes. So when I do 5 divided by 3, the answer is 1.66667 and all of that. But if I should do 5 modulus 3, what would be my answer? My answer would be 2. Why? Because 3 would go in 5 once, and the remainder is going to be what? 2. So this modulus is in brackets integer remainder. So integer remainder of a division. So let me put it of division. So this way we are able to understand what this is. Now, once we are able to know these operators, it's going to shape how we solve problems and how we write our codes. So let me just run this and see. So we see 5 modulus 3 is 2. Now, this is going to shape the way we write our codes and even the way we solve problems. Because sometimes if you want to create an instance where you are working with let's say a calendar, and you want to know if a year is a leap year or not a leap year, one of the ways you'll be able to do that is by using modulus, because you need to divide your year by 4, and you want to know if the remainder is 0 or not, or it's different from 0. So all of these modulus function operators comes in handy in other places. Now the next thing we want to do is we want to also look at the next operator, which is raised to power. We call it caret. This sign that we have raised to power, but we don't use this raised to power sign in Python. We use the double star sign. So if I want to do 2 raised to power 2, for instance, if I do 2 raised to power 2 like this, you see that it gives me 0, because this is not a sign that it understands for what we want to do. But if we do 2 star star 2, it understands this as 4. Now, same thing goes for when I do 3 raised to power 3. This should give us 27. Do we get it? Because 3 raised to power 3 is 27. So if I want to do 9, 2 raised to power 3 raised to power 2. So this is raised to power sign, the operator for it. Now, the next one we want to do is we want to also talk about the relational operators. Relational operators are used when you are comparing 2 values. For instance, I want to say 2 greater than 5, or I want to know if 2 is greater than 5. So for greater than, we already know the sign, which is this sign. So this is the greater sign, greater than sign. Now, same thing goes for less than. So this is less than. Now, there is also what we know as greater less than. So this is not greater and not less than. Are we together?
Yes, sir.
Yes. So now, then we have the equals to. Now, there is equals to that we know less before in maths, but here we use equals to. So equals to here means it is equals to. Because in Python, the equals to sign is not an operator, but an assignment sign. So this sign that we know as equals to in normal mathematics is an assignment sign. I'm going to explain what this assignment does. So what it does is it is used to give a value to something. I'm going to explain it very well once we get to the review.
Hello, sir.
So,
Hello, sir.
Richie, I can hear you.
I think this not greater or less than and equals to we get the same result.
Not completely. Okay. So it's not always in every situation I will get the same result. So for instance, I want to say that if a value is not greater than or is not less than 5,
okay,
it might be like it would be equals to 5, but not every time that would be equals to 5. We'd see where situations like this occur and how it is being handled and how it comes handy also in when we program. Oh, sorry, I made a mistake, sir. This sign is supposed to be like this, and it means not equals to. Sorry, I made a mistake. So this is what it's supposed to mean. So not equals to. Then the next thing is greater than or we know greater than or equals to, and we know less than or equals to. So this is greater than or equals to, and this is less than or equals to. Now, the next thing we also have is a comparison operator. So these are like how do we call it, and or logic, sorry, I said comparison, logical operators. So logical operators are used when we are talking about using logic. So for instance, I want to say if we have 5 and 3, or if we have 4 and 6, how do we undo logical operators like that? So we use this ampersand sign as to identify and the pipe sign for or. So if we have 2 and 4, we use either this ampersand sign. We can also use this and sign, which is already this and keyword, which is already in Python. But we can also use the operators also, like the sign. Please 1 minute, I'll be back. I want to take water. All right, so I'm here. So now we have all of this now. So how do we use all of these operators that we have now? So I think I've shown us how we can use some of these operators. So let's just have 5 plus 3, we see 8. And so now I think we've seen how the normal operators work. Now let me now show us how we use the assignment. Now the assignment is used when, or the assignment sign is used when we are creating a variable. For instance, I want to create a variable called x, and I want to say x should be equals to 3. So now what does this mean? This means that I want to assign the value 3 to x. So whenever I have x, I should see 3 in it. Do we get it? Or whenever I call x, the value 3 is what should be assigned to it. So for instance, I say x equals 3. Now when I say x here, when I call x here, it shows 3 here. So this means that this 3 is stored inside x. So x is a variable here that stores the value 3. Are we together? Are we together?
Come again, sir.
I said
Hello,
that.
sir.
Hello, can you hear me?
Yes, sir.
Yeah, I said this assignment sign, this equals to sign that I said is for assignment. I'm explaining what it does here. So I explained that, for instance, when I create x, I want to create a variable called x. And this x should store the number 3 inside. So whenever I call x, or I say whatever x, or whenever I use x, this value that is stored inside is what it should give me back. So now here I run x equals 3. And then when I call x, it shows 3. Now let me explain what this basically does. If I run a now, for instance, do I have any variable stored as a on this code at the moment? The answer is no. Good. So when I run a, you can see that Python gives an error called name error. What does it say? It says name a is not defined, because I have not defined any variable called a. But if I come here and I say a equals to 5, right? And I run it now, and I call a, what does it give me? It gives me 5. Now, before I assigned the value 5 to a, it saw it as an error. But now, because I have assigned the value 5 to A, it sees A as 5. So whenever I want to use A, the value 5 will be what it would attach to it. So let me explain how this is being used now. For instance, if I say 2 times x, what should I have? Are we together?
Yes, sir.
I said I want to run this operation 2 times x. What would be my output?
2x.
6.
6. Thank you very much. The answer is 6. Why is it 6? Because I have assigned the value 3
Okay.
to x previously. As such,
Okay.
it will give me 6.
Okay.
Are we getting it now?
Yes.
All right. Now, if, for instance, I have A times x, what would be my output?
It will be 15.
15. Good. Thank you. We are getting it now. So if
Yeah.
I say A star star 5, what should be my output?
125.
125. Is that correct? That's 5
Yes.
raised to power 5.
5 raised to power 3.
No, A is 5. Don't forget. A is 5. And I say 5 raised to power 5.
Okay.
That's, do we get it now? 3,105. So
Okay.
now you would see that I am playing around with using numbers and variables.
Yes.
Same thing can go for if I say 3 raised to, or I can say 10 raised to power x. So this should give me what?
1,000.
1,000. Thank you. So now it means that when anything stored inside a variable is what it would see what we have as. So now a variable can store anything. A variable can store anything. For instance, let me say name. I want to confuse us a little bit now. So when I run name here now, what's going to happen?
0.
0. Is that what's going to happen? It's not going to be 0.
Error, I think.
Error.
It will give us back the name.
It will give us back the name. Okay. Why did you say it's going to give us back the name?
I don't know, but I just feel I just feel it will give us
Okay.
back.
All right. Who said error? Why do you think it's going to give us error?
Because name is not defined.
Okay, because name is not defined. The person that said 0, why do you think it's going to give us 0?
Because it's not attached to any variable.
Okay, because it is not attached to any variable. Okay, because it is not attached to any variable, it is going to give us an error. So the name is not defined. It's a name error. So this is a variable. It's supposed to be a variable, but because the variable is not defined, we've not said name should be anything. It sees it as an error. So now we want to say name equals to Nigeria. Oh no, name equals to Bade Jobi. Right? So if name equals to Bade Jobi, now when I run it, name equals to Bade Jobi. So when I call name, what does it see? It gives me Bade Jobi, right?
Mm-hmm.
Now, if I want to print Bade Jobi and I want to say my name is Bade Jobi in Python, how would I do that? I would simply just use a function called print. So there's a keyword called print in Python that does what? It prints out things. And I want to say print my name is, and it should give me name. Now, what have I done here? I've literally said my name is, and then it should print name here, right? So anything that is inside name is what would come out here. For instance, when I run my name is name, it gives me my name is Badejobi. Now, this shows us that what? I can print sentences and create a function or a variable that changes, or that changes based on what is inside. Are we together?
Yes, sir.
Okay. So, for instance, I can see that there is somebody called Temi here. So when I come here, for instance, and I change my name to Temi, and I run it, and I say print my name is name, what is it going to give us? It's going to give us my name is Temi. Do we get it? So now, every time I change this variable, or every time I change what is inside this variable, it is going to always change. Do we get
Sorry,
it?
but I observed something. When
Yeah.
you changed it to Temi, the result for the first one changed to Temi. Or am I getting something wrong?
This name?
In 31.
Okay, line 31. Okay.
Yes.
Yeah, it's going to change to Temi, yes.
Okay.
Yeah, it's going to change. So now, the question you've asked now, let me now explain it further. Now, this tells us that every time we have a variable that changes, because sometimes what is stored inside our variable can change, and every time that changes, what is inside too automatically changes with the output that it gives us. For instance, if I change name to be Murtado, right, and I run it, 36 says name equals Murtado. Now when I come to 37, now it says name is now Murtado. So when I change, we come here now and run my name is name, it should change my name to what? My name is Murtado. So this is how variable works. Variable can store a number, it can store a string of characters. It can also store decimal. So when I say a equals to 5.5, when I run a, it gives me 5.5. Are we together?
Yes, sir.
Good. So now, let's now do something. Let's now play around with the relational operators. I want to say, is a greater than x, for instance. So if I say a greater than x, what should this give me? This would give me a Boolean. This is a Boolean question in Python. So it sees it as a true or false. Boolean is true or false. So this is a Boolean question or Boolean operation because it's going to give us either a true or a false. Now, A is what? A is 5.5. X is what? X is 3. 5.5 is greater than 3. True or false?
True.
True. So when I run this, it gives me true. Do we get it?
Yes, sir.
Yeah. Now, same thing goes to when I say X is greater than A. What's this going to give me?
False.
False. Because X is not greater than A. So when I say X is greater than or equals to A, what's this going to give me?
False.
False. Now, when I say X less than or greater than A, what's it going to give me? This is less than or equals to, less than, greater than. So what's X less than or greater than A going to give me?
But that's not equals to, right?
Yes, so this means not equals to. So X, so what I expect us to do is we are to automatically like
give us
interpret.
true.
It will give
It
us
will
true.
give us true.
Okay.
Yes.
Okay. Any other answer?
True.
True. Okay. So it's going to give us an invalid syntax. Why is it giving us an invalid syntax? Okay, it's giving us an syntax error because it doesn't understand this, or it doesn't take this. So now, another way we can do or identify not equals to is, oh, I forgot to even mention it the other time, is to have something called exclamation equals to. So exclamation means not, and equals to here is equals to. So let me add this here. So, oops. So when I run this now, it gives me true because it says this is not equals to. Okay, so the next one we want to have is, okay, so we have all of this now. So now, any question?
Yes. So I tried running this name equal to on my own. It's not giving me any result.
This name equals to what?
I used Temi and it's not coming up with any result.
Is the Temi in quotes?
Yes, so it is.
What's it saying? Okay, when you run it, it's not giving any result. Yes, it is not
Any
going
result.
to give. Yes, but when you run name now, it would give you. It would now give you the result. So what this line does is it assigns the name Temi to the variable name called name. Do you get it? So it doesn't print the name automatically. It just assigns it to it. Then when you now come to the next line and give the name or mention the name, it is now going to give you what is.
I get it now. It was case sensitive. I didn't know it's case sensitive.
Yes, Python is case sensitive. Yes.
Thank you.
All right. So now let's now get into something quite deeper now. Next thing is writing and executing Python codes. So now we want to write codes, Python codes now, and then we want to see how it works. So yeah, I forgot to mention, when you want to have a comment. So a comment is a code that does not affect your code. It doesn't affect your line of code. But basically, it helps the reader, the person reading your code, to understand what is inside your code. Do we get it? So, for instance, I have to do that in Python. You use the hashtag sign, this hash sign. You put that before the line, the words that you want to have. In SQL, I know you've done SQL. So in SQL, you use the dash sign, but in Python, the dash sign is not for comment. So these are some of the things that you need to remember whenever you are executing codes or writing scripts in any language. So let's start. But before we start again, I also want to talk about certain things that we have, which are called keywords. What are keywords? Keywords are inbuilt words already in Python that you cannot use them as variable names. For instance, I want to have a variable called let me think of one. What variable name can I have that would not work? Okay, I want to have a variable name called random. Random. So when I write random, it works, right? But when I have so I can have a variable name called random that holds like random numbers. But if I have but I cannot have a variable name called something like print, for instance, because print itself is a keyword in Python. Now, one of the ways to know keywords in Python easily is that it changes, the color of the word automatically changes when you've written it. So if I write print, I write and, I write or, I write if, I write else, I write elif. You can see all of these words that I've written, the colors change. So once the color changes, it tells us that this word is a keyword in Python and we cannot use it as a variable name. Do we get it?
Yes.
Yeah. So so now let's now write certain things. For instance, I can have decimal, but I cannot have float. I cannot have I can have integer, but I cannot have int. Now, all of these keywords that we have, they all have a function that they perform. For instance, if I want to make a data or a value that I have come in an integer form, right? An integer is whole number. All I just have to do is make it in form of int. Now, let me explain what I have here better now. For instance, if I say 5.5 and I want 5.5, I have 5.5 here, right? But when I come here and I say int 5.5, what am I going to have? Any response? Any answer?
6.
6. Any other person? Any other person? Okay. So when I run this, I get 5. Now, why did it give me 5 and not 6? Like I mentioned the other time, int gives what? It returns whole number. Now, it returns the whole number of what we have. So the whole number in 5.5 is 5. Now, by default, we expect that, it should round it up to 6, right? But that does not work unless you use certain functionalities or certain keywords like something called ceiling. Oh, C is supposed to work. Okay, maybe it doesn't work here. Okay, so there's something called ceil and there's something called floor. So ceil is ceiling, which returns the value that we have, like how do I call it? It rounds what we have, the number that we have, it rounds it up, and floor rounds it down. When we get to NumPy, we'll see functions like this. But basically here it doesn't work. But we can use another function that does that, which is round. What round does is round basically rounds up a number. It basically rounds up a number and it rounds it to the nearest whole number that we have. The nearest whole number or the nearest decimal place, depending on what we've set. So for instance, if I have 5.456, this is going to give me 5 because in rounding up mathematically, it uses the last value to round either up or down. Do we get it? But if I want to say round up 5.456 to the nearest 2 decimal place, what this is going to give me is what? I'm going to say round 5.456 and I'm going to put the number of decimal place that I want at the front. So I'll say 2. So by this, when I run this, it's going to give me 5.46 because now it is going to round up the value before what's it called? Before 5, which is the second decimal place, and it is going to give it 6. So this is the difference between integer and round. Do we get that? Are we together?
Hello, sir. Yes, sir.
Yes.
Hello, sir. If
Yes.
we are using round, we don't need to read. We don't need to use a floor or ceiling again.
Yeah, we don't need to use floor or ceiling. Like I said, floor and ceiling only work in NumPy. So by the time we get to NumPy, we would see how floor and ceiling works. But in Python generally, what we have is round. So I would personally advise, I personally use round because it's easy to work with, and also I don't have to bother myself about rounding up or rounding down, when all I just have to do is state what I want. If I want to round to a whole number, or I want to round to based on decimal place. So depending on that, that works. Now, another thing that I want to also talk about is how we get user interactivity from Python. So for instance, I want to create something quite interesting where the user gets to input a value, right? So for instance, I say, so there's a keyword called in, right? What this in does is it gets input from a user. For instance, when I say in, I say what is your name, right? When I run this, it is going to get the username from me. So when I run this, for instance, okay, it says there's a problem with in, so we use input. In and input work the same way, so that's not a problem. So when I say what is your name, now you see, now when I run it, it says what is your name. It expects me to put my name. So when I put in Murtado, it's going to give me Murtado. Do we get it? Do you get what I've done?
Yes.
Yes. Now, I want to make this quite interesting now, which is I want to assign a name, a variable called name, or let me say username, to this, right? So this variable now, any name that the user inputs would be assigned to the username, and then I want to say print what? Hello, and I say username. Now, okay, let me just remove this one. One of the things that you would notice when I use this hello and username is, after hello I put a comma, which basically separates this string from this variable. Now what I want is, I want or let me just say, yeah, I want this, and I want to say hello name, and I say \n, welcome to our data analysis class, or let me say welcome to our Python class. Now I'm going to explain what I've written here, but before I do that, let me just show us what happens here. So when I run this now, it says what is your name. So my name is I want to put, which other name do we have here? I think we have Idris here. So when I come here and I say Idris and I run it, it says hello Idris, welcome to our Python class. Do we get it? Now, how does this print hello Idris, or how does it know that Idris is the name it is supposed to print? Now, this thing is supposed to be right. It's not working. It says okay, so now how does it know that it is supposed to print Idris? Now, it prints Idris because I have literally set Idris to be the username that should be assigned to this variable. So anytime I call the variable username, it should give me whatever is stored inside. So when I run this again and I say I another name. Let me look for another name. Solu, for instance. So when I say Solu, it gives me hello Solu, welcome to our Python class. So now this way it makes it very much easier to get what's it called, to get inputs from user. Now let's now make this much more interesting by creating more input values and using the variables that are assigned to the that are gotten from the inputs for output. Now, so let's say I have a username called what's it called, name, and then I want to also have another variable called age, and I want to say age equals to input how old are you, right? So now I want to say hello, and I have the name, and then I want to say you are let me just use you are, and I want to say age years old. Are we together? Now, what I have now is I want to get input from my user, and I want to tell I want to print out the name I get from the user and their age. So when I run this now, it runs the first line, which is what is your name? My name is Ade. I run it, I press enter. It says how old are you? I am 10 years old. So when I press enter, it says hello Ade, you are 10 years old. Do we get it? Are we getting it? Are we getting what we are doing? Any question?
Hello, sir. Hello, sir. Can you hear me?
Yeah, I can hear you.
Good morning. Please, I will really appreciate when doing the examples. I will really appreciate if you kind of leave the one that you've done and try and do a new one instead of editing. The reason is that at times the example that you have done will help us in seeing what you want to do the next. But when you are using the same will I say query or code, and you are just juggling around it makes it kind of difficult for us. For me, let me not generalize, for me. So that's what I just look at and I say
It's the same thing. It's the same thing with me, because if we have the former one as sample, so we'll be able to see the difference between the former sample and the new sample.
All right, I get you. Yeah, thank you for that. So let me just use this then and say, let's just have so now I have this. So we have okay, we run this and we say Ade is let's say 20 years old. So name is Ade, the age is 20. So it says hello Ade, you are 20 years old. Now let's now
I have one more question, sir. One question,
all
sir,
right.
please. The username that you wrote, where did you define it?
Okay, so the username in its definition, what it does here is that any input that the user puts in is what would automatically become the new username. Unlike previously where we created username and say, okay, the name should be equals to Murtado. For instance, here now, the name now automatically becomes what the user inputs. Do we get? So this one is
Okay,
static.
now, so when you run it, because I've not been following network and I've not been seeing everything that you are doing. Even I don't know that you'll be hearing me now. I just keep mute, but I just say let me try my luck. Thank goodness I mean now I've been following, here and there. I've not been getting it. Even I've not been able to launch anything because I was unable to start with you people. But now I can see that when you say the username now, when you run it, it's a message you now prompt bring come up like, okay, enter the name, right?
Yes.
Okay, sir. Okay, then the for running it's still the same F5.
Oh no. In Jupyter Notebook here, we use Shift Enter to run. Now, Shift Enter, you can run it in various ways. There's no static one way to it. Now, this is one of the good thing about programming. There is no one way to doing something. One of the ways you here is you can press Shift Enter when you want to run a cell, because each of these are called cells. When you want to run a cell and automatically you want to select what is below again, you want it to create a new cell at the bottom. Another way you can do it is you can come here, this run button here, you can literally just click it. And when you click it, it runs what is inside the cell that you've selected. Do we get it? Now, this prompt that comes up for the user to put in the name comes up because we have this function called input. So this input is a keyword in Python that requests the user to put in something. Do we get it? It requests the user to
Okay,
put
sir.
in
So
something.
it's still the same. The input and the in, they are doing the same job.
Yes, input and it do the same thing. The only difference is that we are presently using Python 3. In Python 3, the keyword for input is input, so that the user would input a value. But in Python 2, the in is the keyword to input. Do we get it?
So maybe in Python 3, I decide to use in. What will happen?
So in Python 3, when you use in, it is going to give you something called a syntax error. So let me show you what it
Okay.
means. So let me say,
No,
for instance,
don't worry, don't worry. I've already gotten it. I've gotten
yeah,
it.
then I need to explain
My
something.
my own question, sir. My own question, sir. Before you go.
Okay,
Hello, sir.
I'm with you.
Yes, sir. Yeah, when you write a user's name equals input what is your name. That means what is your name is the variable of this user's name. Now, when you now come back to write print hello, that is, it should respond with user's name. Now, what is the code that is used to bring this welcome to our Python class? Is it a continuation of this input?
Okay, so like I said the other time, input is to get value from the user, right? Now, to output what you have, like to print there is in computer there is input, process, output. Input is you put in something, it processes it, and then it gives you an output. To get an output in Python, you use the print function.
Yes.
Now, this literally just gives you what you have. Now, anything you have inside quotes is going to print it out for you. But when you now have a variable, when you want to call a variable, all you need to just do is put in the variable, like you separate it with a comma, and put in the variable name that you've created. Now, if the variable exists in terms of a value being attached to it, it would give the response based on what you've created in your variable for the output. So here, what I've done is I said print hello, then add the name that has been attached by the user, what the user has input as his name, to now say hello, the username. So if you change the name here to $1, for instance, so if the user inputs, so when you say, when Python runs and says, what is your name? And the user says $1, right, the next thing that would come up would be hello $1. Do we get it?
Yes.
So that's just it. So if you wanted to do another thing, hello $1, enter your what's it called, your age. So it says $1 now that is the user puts in 25. So it says I $1, you are 25 years old. If the code that we've written is basically to what's it called, to check if $1 is qualified to be a driver in Nigeria, you could say you are qualified to learn how to drive, or you are qualified to drive on the road in Nigeria. But if $1 is probably less than 17 years old, the program should say, hello $1, you're not qualified to be a driver. Do we get it? So we just want to create something that we can easily flow with, and it is not static. It is not, oh, I have defined the name to be a particular name, and then that would be the only name that it would be with. So that's just what we have. So I just want to explain what in would do if we have in. So if we have in Python 3, it is going to be useful when we have other things later on, when we are writing certain codes in data analysis. So when we have a list, for instance, and we want to check if the value we have is inside a list, what we would use will be in. We'll get to that part when we get to array, list, and other aspect of Python. But for now, this is just what we have, and whenever we want to get input from the user, we use the input function. So let's just say get the name. So let's just use another name, Olawale. So name is Olawale, enter. Age is 20, enter. So it says, hello Olawale, you are 20 years old. Now let's now move to another part of what we are supposed to discuss, which is Python function and control structures. Now here now we've been able to run a simple Python code in its form, like a simple one. But how then do we now create a control structure or a function that we have? So
Hello, sir. Hello, sir. Hello,
Yes.
sir. Before you go ahead, in this N60, sir, what is the
Yes.
work of this slash in this N60? We have username input. What is your name? Print hello
Okay.
username. What is the work of this slash before welcome to our Python class?
All right. Thank you
This
very much
function.
for that. Yes. Thank you very much for that beautiful question. So I was going to explain that in Python function and control structure, but yes, let's now talk about it here. So what backslash does is that it creates a command, it creates a flow. So there is something called backslash n. So backslash n creates a new line. So it says anything that comes after me in backslash n, put it in a new line. Do we get it? Now, if I add backslash t, for instance, it's going to create a tab. It's going to create a tab. So when I run this, for instance, I say Bola, it's going to say hello Bola. Now you see that instead of taking welcome to our Python class to a new line, it creates a tab, like a space, a very big space in between.
Okay, sir.
So this is what this does. We can also understand more of this when we do. We can just read backslash Python. So we'll see the various backslashes that we can have. We can have backslash t, like I said, for tab. We can have backslash r for a carrier, like a new carrier return. We can have backslash n for new line. So these are just some small string control structures that we can have in Python. So now I explained the other time that if we want to comment out a line, we use the hashtag sign, right? Now, if I want to comment out multiple lines, how do I do that? Because all of this line now, I don't want them to affect my code. What I can do is I can highlight everything first and do hashtag 3 times. So I have one, oops. Okay, let me do it like this, simply. We have hashtag 3 times here at the top and at the end. What have you done? It did not work. Okay, yes, it did not work. The reason why it did not work is I did the wrong thing. So for us to comment out multiple lines, you are going to use the quote, this single quote. Let me show us the single quote. So we are able to, this single quote that we have, we are going to have it 3 times. So we are going to have this guy 3 times. So anything you have inside this is a multi-line comment. So when I want to comment out this now, all I just have to do is I'm going to tap my single quote, the button beside enter on your keyboard 3 times. 1, 2, 3. Did you see that? So it's going to automatically change this to a multi-line code, and it does not affect whatever we've written, basically. And yes, I forgot to show us something. Another thing I forgot to show us is we talked about codes and the other cell type that we could have the other time, right? The code, markdown, and raw converts, and how they we can actually use them. So I think this is also a very good place to use things like this. Now, when we have words like this and we don't want them to affect our code, we don't want it to do anything, we can literally change our cell type to markdown here. So when you click markdown here, automatically you see that it changes what we have here, and it does not affect the code. Now it changes the structure also of what we've had. So Python, like we have it before, all of the codes we've written like previously, you see that here now this looks like a much more cleaner what's it called, structure, because this cell itself is not in the code form, it's in the markdown form. Shall we get it? Then when we want to edit it, we can just double click it and then we can edit. Then we can add to it. We can use this dash. It sees this dash as an index itself. Shall we get it now? So Python function and control structures. Now we want to talk about functions and methods that are inside Python. Then we want to also talk about control statements. Now, we've talked about certain functions that are inside. One of the functions we talked about is input, and we talked about the print function. We've also talked about the round function, and now we want to talk about which other function can we talk about? We want to talk about a function that automatically controls what we have. For instance, we want to make sure that anything our user inputs follows a particular data type. Are we together?
Yes, sir.
Yes, sir. Good. So let me give us an instance. For instance, you know that it is possible that when I run this this code that says, let me copy this code, and I run this now. You know, it is very possible that when I run this code, it says, what is your name, right? And me, that I'm a user, I decide to input a number, and I say 988 or 989 is my name. Are we together? Logically, yes. Is this correct?
No.
No, because this is a number, and we expect a name, but this is not given. So we input it, and I says, how old are you? It says Yetunde. Now we expect the user to input a number, but the user decides to input a string, a name. So it says, Python says, hello 989, you are Yetunde years old. According to what we've written, is this correct?
No.
Yes.
According to the code we've written, is this correct?
Yes.
It is correct. But according to human logic, is this correct?
No.
No.
No. So sometimes, like we are users of different applications on our phone. Users can be very, very funny, and they will just want to try your software or the code that you've written and kind of put problems inside it. So how do we undo things like this? So these are where certain functionalities also come into what we write as codes in Python, or whenever we write scripts in Python, we are able to control whatever the user inputs. So for us to now make this thing much more better, let's now run our code again. So this time around, I want to make sure that the user inputs a string. Now, what is a string? A string is a collection of characters, and a string is like I said, is a collection of characters. It could be a number, it could be an alphabet, it could be anything. Shall we get it? It could be anything. Now, that is a string. What is a float? A float is a decimal number. That is literally a float. In Python, it's a decimal number. What is an int? An integer is a whole number. Shall we get it? Now, once we understand this, we are able to what's it called? Understand what we expect from our users. So I want to say that we want to get a name from our user. The user should input a name. Now, any name this user inputs, we want to convert it to a string. We want to convert it to what? A string. Now, to convert whatever the user inputs to a string, we say that what? str. And then we put whatever the user inputs inside it. So this tells us that it should convert whatever is inside this string, inside this, whatever the user inputs, basically convert it to a string. That is what this does for us. Also, we want to do that to the name, and we'd say integer, because we expect our name to be an integer. And we say whatever the user inputs as age, and how old are you, it should convert it to an integer before assigning it to this variable called age. So now let's run this. So when I say, what is your name? And I say 989, and I press enter, and I say, how old are you? It says Yetunde. Now when I run it, what does it tell me? It says that what? There's an error, right? And what is the error? A value error. Are we together?
Yes, sir.
Yes. Now, what does this value error tells us? It tells us invalid literal for what? For integer with base 10. Yetunde. Now, what does this mean? This means that the user has imputed or has input an invalid value called Yetunde. Now, this Yetunde is supposed to be a what? A number in base 10. By default, our numbers are in base 10. So it expects that the user inputs a value that is what? That is in base 10 for the what? For the age. Now, you would also see that here, it puts an arrow showing where there is an error. Are we together? So now, when we have things like this, this controls how the user inputs values for our codes. So now this would automatically tell the user to go back and put in the right things. So if the user goes back and puts 989, for instance, and puts, okay, good, and puts 89 here and press enter, it says, hello 989, you are 89 years old. Now, let's now ask the question I asked previously. From the code we've written, is this correct?
No.
From our code here, is it correct?
No.
No. Why is it not correct?
When you say
It's
name,
correct. It's correct, sir. It's correct because we use string for the what is your name? We use string. Where we are instructing it to put either number or alphabet.
Thank you very much. Yes, I'm with you. Yeah, thank you very much. So, like we said, we expected that, like I explained, we explained that a string is anything. Either it is a number, either it is an alphabet, either it's anything. A string is anything, any character. A collection of characters is a string. So if you put in number where you're supposed to have character, you are also correct. And where you're supposed to have string, you are logically correct because a string is a collection of that. Now, but in terms of integer, we see that it makes sure that the user inputs a number. Now, how do we make sure that the user inputs a name, like a character? So what we can have is, we can have something called an object. But we have to be careful with an object because objects can be very, very wide in the way it handles, it handles values. So, but let's see what would happen when we have an object. So when we run this and we put in 989, you see that it automatically gives us an error. Why? Because it says what? Object takes no argument. Now, this is one of the challenges with objects, that is also a data type itself. But in this part, we would not be able to use things like this. But when we get to analysis, when we input data and we start seeing objects, we would be able to see why we have objects in those places. So in situations like this, what do we do? One of the ways, or one of the things that we do, is that we try as much as possible to make sure that we understand, or we create what's it called, a command for the users so that they are able to work with it. So how do we do that? One of it is we say we put in certain controls. For instance, we can put in \n here and say please input a valid name. So when we run this now, we see here that it says, what is your name? And then it says, please input what? A valid name. So this way, the user automatically knows that, oh, I am supposed to input a name that is valid. Are we together?
Yes, sir.
All right. So that is why sometimes whenever we use certain softwares or websites, we see that they would put in a text box that needs a name in it, and inside, under the text box, they will put like an asterisk control to just say put in something that is valid, just to make sure that the user is reminded of what is needed in that particular cell or that particular text box. So let's just use Adebola. And then here we says, how old are you? We have 70. So it says, hello Adebola, you are 70 years old. Do we get that now? So now, another part we want to now go to is conditional statements. What are conditional statements? conditional statements are things or words or statements basically
Hello? Hello? Hello?
I think it's
You'll be
not
back, I
six.
guess. You'll be back. Let's just have patience. Hello? Anybody there, please? I just
Yes,
need
yes, yes.
a guide. I just need
Yes,
a
yes,
guide
certain.
because I came in so late. You guys have already opened this thing before I came in. Please, how did you launch the app is using?
yeah hello,
Yes.
can you hear me?
Hello?
Yeah,
Yes,
hello,
I can
can you
hear
hear me
you.
now?
Oh,
Some of
okay.
us.
Don't worry. Let's continue. I think I can use that window to get what I want to get. Let's continue.
Okay.
Thank you.
Can you see my screen?
No,
Can you see my screen?
no.
How about now?
Yes.
Yes.
It's up now.
Yes.
Yes.
All right. So let's continue.
You have stopped sharing.
Can you see my screen now?
Yes.
Okay, all right.
Yes.
So let's continue. So I was talking about conditional statements now, and so sorry, who's that? So I was explaining that conditional statements are conditions, like if statements that are not executed until a certain condition is true. If the condition is not true, the conditions would not be executed. So these are conditional statements. And in Python, the conditional statement here is if. For instance, in SQL, the conditional statement you have there is case. Am I right? Are we together?
No, sir.
Where are we lost? I said that in Python, for conditional statements, our function for conditional statements is if.
Yes.
Now I said that in SQL, our conditional statement is case. Like the function for conditional statement in SQL is case. Am I right?
Yes, yes, you're right.
All right. So now in Python, it follows this structure of if. Let me just follows this structure of if, elif, else. If means if a condition is true, do something. Elif means if, else, if. So elif is a combination of else and if together, and that's why we have elif. Now, but there's a difference between else, if, and elif. Now, the difference is that in elif, it is a new condition on its own. But in else, if, it takes the whole else first. So let's say if you are a boy, if you are a boy, how do I say? If you are a boy, you are male. Else, you are automatically female. Like that's how it is. But if you now put else and then you say if under else, it takes the whole what's it called? The whole condition now as under else first before seeing it as if. So what do I mean? So let's say if I say if age less than 18, print you are a small guy, something like this, for instance. And then I say else, and then I say if. Now, this would automatically split this to two. It splits this to two first, where it says if you are not 18, if you are less than 18, and this is if you are greater than or equals to 18. Now, if you are now greater than or equals to 18, I now want to split again. Now, instead of doing this, what you have is elif. Now, in elif, you create a condition again. So you have if condition, elif. So I want to remove this. Elif, another condition, then else. In else, you don't create conditions. By default, in else, you don't create conditions. So this way, you are able to work with other things. Then also, it is better to always put your conditions in a bracket, especially when you are working with multiple conditions. Especially when you are working with multiple conditions, it's always better to have your bracket so that it is easy to understand and read by anybody. So now let's say age is how do I want to do it? How do I want to do this now?
Above 18.
Yeah, above 18. Yeah, but I want to think of an approach where I'm able to like split. Okay, let me just use different age. So let's say less than 18, or let me say less than 20. I will say first I should even have less than 10 or less than 13. Sorry, let's start with less than 13. you are
Teenager.
a teenager is 13 to 19. So less than 13, we want to have a, I don't know what to call them. Let's just call them adolescent. Okay. Okay. So then we say age less than 20. When we first enter, now one of the things you would also notice is something called indentation here. Indentation is when you press enter here, automatically it doesn't take you to this line where you have else, where you have if and elif. It takes you to a line that is under it based on tab, because Python uses something called indentation to control how it sees or how it reads commands under each of these functions, especially for conditional statements like this, or anything that has conditional statements and even loops. So we are going to get there. So here we would say you are a teenager, something like this, and then we can also say elif age less than, let's say, 40.
30. Youth.
Just want to say
Youth.
yes, youth. So you are a youth. So we want to just say else.
Adult. Adult.
So something like this, for instance. So when we run this now, okay, yeah. So it says name print is not defined because print is a. Now, why did it print you are old? Though? Because, okay, yeah. Who can answer this question? Why did it print you are old? Though? Anybody? Why did
I think like you said, it will the S will take it will take the superpower on every other thing.
Okay, but yes, that's true. But actually, that's not the reason. Well, what you said is true, but it's not the reason why we have you are old though, after we've done this. So the reason why we have you are old though, is because, like we said, we created a conditional statement, a condition on what? On age, Abi? Are we together?
Yes, sir.
Yes, we created a condition on age. Now, what is the last age that is stored inside? So let me show us what we have inside age. So when we run age, what is inside? What does it give us?
70.
70. Now, all of the conditions that we've had previously, where does 70 fall under?
60, 73, okay.
Seventy falls under else because every other condition that we have are less than 40, less than 20, and less than 13. Am I right? Are we together?
Yes.
Yes. Okay. Now, let's now go back to this code that we used to generate our age, and let's now do something again, and let's now see what's going to happen. Also, I want to now bring in this, our code that we have here. I want to bring it inside here, and I also want to bring in our condition that we have here. I want to bring it inside our this cell. So everything is going to run together, right? And I want us to pay attention to the code we have written so closely so that we are able to understand the conditions and that we have set and how to control our conditions, like how to set control structures. So let's go. When I run this now, it says, what is your name? Input a valid name. my name is what name should I use now? Let me use Andrew. Right? I press enter. It says, how old are you? I am 20 years old. Now, when I press enter, what does it say? It says, hello, Andrew, you are 20 years old. You are a youth. Now, why does it have youth for 20 years old? Can anybody answer that?
Because when you stated the S if, age under the age less than 40. So you said, yeah, he said you should print out you are a youth, and which means 20 falls under the less than 40. It doesn't fall under the you are a teenager, because you are a teenager is less than, not less than, equal to. So it won't take the 20 as part of it. It will take the less than 40, which is S if elif age less than 40. I think that's the reason why it took the your youth.
Yeah, thank you very much for that. That's a beautiful response, and that's the answer. So, because in our conditions, what we set was less than 20. Now, one of the things that Python does when it's running conditions like this is it goes one condition at a time. So, first is it goes to the first condition, takes to the next condition, it goes to the next condition, then it goes to the last condition. Shall we get it? So, if if for instance we set our less than 40 as the first condition, so let me show us something. So if we mistakenly set our conditions to be, sorry, I have to edit this now, 40, 20, and let's say 13, and we say this one is you are a youth, and this one is adolescent. Now if we run this code again, if we run this code again and we say what is your name, and it says Josh, and it says how old are you, and it says 13, what is it going to give us? Can anybody answer this? What is it going to return for us if we put in 13 as the age now? Is it going to return youth, teenager, adolescent, or you are old?
You're going to return youth.
Youth, right? It is going to return youth because, like I explained the other time, the conditions start from Python runs the condition from the top to the last. So the structure in which you set your conditions will determine how the how Python would interpret all of the things you've written. So that way, it's always better once we understand this that we set our conditions.
Hello, sir.
Yes.
So if I get you correctly, Python, we always look at the way the condition is set. Now, because looking at this now, I think the reason why it picked you a youth, because you wrote it first, was that the age 13 still falls under less than 40. So instead of running everything before taking his answer, Python will just look at the first conditional statement and see that, okay, it falls under it, then it just pick it. Is that what you're saying?
Yes, that's exactly how it works. So the first condition that it falls under, that's what it's going to pick. So it's not going to go through all of the conditions and then say, okay,
If we
this one
just
falls
ignore,
under
if
this
we
one.
just ignore everything that we are writing, elif, everything. Why now? Waiting. Why?
So that's why we need to understand how Python thinks so that we are able to structure our codes correctly also. Sure you get, because these are some of the things that when you start writing codes, especially when you are doing analysis, and then you've gone to set a condition for another thing, thinking that this condition is correct logically, but when you run it, it would give you a different logic because of the structure we've used. So now I think with this, we are able to understand some of the structure or the ways Python interprets all of these things. Now, the next thing we want to go into is we want to look into loops. So we have.
Hello, sir. Hello, sir.
Please hold on a bit.
If we want Python to interpret this according to our iteration, our original iteration is that if age is less than 30, it should interpret it as adolescent. If age is 20, it should interpret it as a teenager. If age is 40, it should interpret it as youth, or else all others above 40, it should interpret them as old. Now, if we want this our iteration to be interpreted, what do we do to this code?
All right, thank you very much. So what do we do with this code? Now, what we do is, so to correctly interpret conditional statements, what we should do is, the best thing to do is to use limits. What does limit does? Limit is we create a bound. We create a bound. So we have an upper bound and a lower bound. Now, let's rewrite this code and see how it works now. And this time around, we are going to make it so that it is a logic. It is not in the same structure. So how do we use upper bound and lower bound? For instance, I want to say if now we want, we said from 20 to 40 or from 20 to 39 should be taken as youth, Abi. So what we'll do is we'll say if age is so we can do it two ways. We can do if 20 greater than now this is again a big problem. If age is less than, what are we doing? 20 greater than or equals to age, and age is less than 40, should give us youth. If age here for teenager is from 13, right? So we say 13 greater than or equals to age, and it is less than 20, we say teenager. So here we say if age is less than 13, we say adolescent. And this other one. Now, what have we done here? We've created a limit here. So this is our lower bound. Our lower bound in terms of if 20 is greater than our age, or age itself is less than 40, that is when it should have youth. If 20 is not greater than age, or is not equals to age, it should move to the next condition. So let's run this and see how it's going to work. Although this is a mathematical structure of how to write lower and upper bound. In fact, this could be correct and this could be wrong. Let's see. Now, when we run this, what does it say? Let's use 13. No, 13 is teenager. Let's use
a name.
12.
Name.
Okay, name.
Please input the name.
Name is Agu. Agu is 11 years old. So when we run this, what does it say? It says what? You are a youth. Now we'll see that when we use the mathematical approach of writing bounds in Python, it would not work. Are we together? Now, because these are some of the things that we need to know when we are learning. Because sometimes we might feel like, oh, this thing should work, and then it gives us a problem. Now, how then do we make this thing work? Now, then we now have to use what's it called? We have to use our logical operator. Now let's now go back to it. How does our logical operator works? We say age age is what here? Age is greater than or equals to 20. Are we together?
Yes.
And open another bracket, age is less than 40. Do we get it now?
Yes.
Now we go to the next one. We say so here we say age is what?
Age.
Greater than 13 and age is less than 20. Then teenager. If age is less than 13, adolescent. Else you are old. Now this now works in terms of the logic now, where we are able to check if age is greater than or equals to 20 or and age is less than 40. So this condition has to be true for this to be work. So if this condition and logic are not true, this would not work. So let's use Agu and age again and it's 11 years old and see how it's going to interpret it now. So let us run this. So we use Agu and 11. Now we now see that it changes this to what? To adolescent, because we've used the right logic by using a lower bound and an upper bound for age itself. This is the correct way to do it. Although, if we don't want to go through all of this in terms of creating logic and all of that, the go-to method is to just create the conditions in a structure where if one condition is not met, it goes to the next one hierarchically. That way, it helps. But this is a very slow method because if you have 50 conditions, for instance, it would have to go through each of the conditions one after the other, one after the other, one after the other, one after the other. But when you have logic alongside with the conditions, it is able to check within time. Does this work? Does this work? No, it doesn't. Does this work? Does it work? It doesn't. And then it runs the code faster. So are we together now?
Yes, sir.
All right. So let's go to the next one, which is the loop. So what is loop? And why do we use loop? Hope you are not tired.
We are not tired, sir.
All right, good. So we are together. Now, what is a loop and why do we use loop?
No, sir, please, where are we going for a break?
I was told by 11 o'clock. By 1 o'clock.
11 o'clock. Let's go straight so that everybody will to go to his own way because of data and battery.
We are supposed to, sorry, sir. Sorry, Mr. Falaye. We were supposed to go for a little break. That's a normal thing. Just
I was told that we should go for a break by 1 o'clock.
Okay.
It's done now. It's 8 minutes to 1 o'clock.
Yes, I just want to explain loop, and then by the time we are back, we will talk about loop, and then we would practice some exercise. So this would be what we would have for today. So now, what is a loop, and why do we have loop? A loop is a recursive function. Recursive in terms of it goes again, like an iteration function that goes again to perform an action until a particular condition is met that is false. So a loop would continue to run for every condition that is true until a condition is false, and then it will stop. Are we together? So once a condition, a loop is a function, a recursive or an iterative function that runs until a condition is met. Once that condition is met, either it is true or false, it would terminate depending on what we have set. Shall we get it? Now, I'm going to explain this in a simple term. For instance, we have 10 students, right? We have 10 students, and then we want to say that we want to get the age of each of these students until we get the 10th student. So this means that we are going to run, our code is going to run 10 times, getting the age of each student. Are we together? Previously, we had what is your name here, like the username would run just once here. But when we have 10 students and we want to get their name and their age, our loop would run the same code 10 times based on the conditions that we have set. Once the condition is met, it would terminate. Sometimes, if we set a condition to run, once the condition is not met, it will terminate. Now, this varies based on for loop and while loop. Now, what is the structure of for loop? For loop runs by using a for condition. So there is a keyword function for, and it takes in an argument. What is the argument it takes in? It takes in a variable, 1. It takes in an increment. It takes in a variable. Let me just put variable. It takes in a variable. It takes in an increment, and it takes in an end. After this, when you use it, you put colon, and you press enter, and then you have the condition you want to put inside. So if I have for a condition to run, incrementing to a particular level and ending on a particular point, do so and so. Let me explain. So if I say for x, or let me use something that we've not created for y, incrementing y plus plus, and I say 5, and I say print y. What is this going to do for us? When I run this, it says invalid syntax. Now, why is this invalid syntax? Because I've written a syntax that is wrong. Okay, so now it says cannot assign to operator. Now, why does it cannot assign to operator? Because the variable I've set here is not assigned to anything. So let me say y equals to 0. So I say for y equals to 0, y plus 1, ending on 5, print y. So now when I run this now, it says again invalid syntax. What's wrong here? 1 minute. Okay. Oh God, this life. So I want to say for y in range 5, print y. Okay, so now let me explain what I've done. So here I say y. I created a variable that we've not assigned any value to before. And I say for y in range 5. Now range 5 by default. So when we come here, range is another function. Now what range does is it creates a list starting from the beginning to the value we have set, depending on the condition we use. And then it creates a list for that, and inside that list, I talked about using in the other time, and I mentioned we use in when we have lists and arrays. If we remember, the other time I talked about in. So now we want to create a function such that everything in this list that we have here, is automatically iterated from 0 to the last number 5. So it goes 5 times starting from 0. So 0 is the first step. Next one is 1. Next one is 2. Next one is 3. Next one is 4. Now, these are 5 steps that it has gone through based on what we've set. And then we say it should print whatever is inside it. So for each of the time it goes through the list that we have, it prints what is held inside the list. So this is how for loop works. Although,
Hello, sir. Before you move on, the 5 you wrote is the step, not actually the figure that we are seeing.
yes, it's the step that I should run.
It's the step that it will run. So
Yes.
now that means, and it has to start from 0.
Yeah, it's going to start from 0. Now, but one of the things that we should also note is that the 5 here is the step. But if we look at the range 5 that I've written here, the range 5, basically what it does is it creates a range from 0 to the 5, to the number that we have set inside the range. Do we get it? So for us to understand the numbers of value that is inside this range 5, we can use another function called length. So we want to see what is inside this. If we do this now, we see that it is 5. So the length of numbers of values that is inside range of 5 is 5 itself. So it holds 5 values inside. Are we together?
So what did you write?
I wrote len. So this len is
Len.
Len, yes. It shows the length at which a value or a variable or a function holds something. So for instance, if I want to check the length of a name, our name the other time was Montado, right? So if I come here and I say len of name, it shows 8 because name is what? Is Montado. So when we count Montado, M-U-R, and count everything, there are 8 letters in it. Do we understand it now?
Sorry, please. This thing is getting interesting. This, as you are writing all this code, the query, the one anything that you've already assigned, because I remember when you want to start this loop, for loop, you decided not to use X.
Yes.
Nothing that you've already defined X up there.
Yes.
And also you came down here, you used length and put name inside because you have already assigned name also, which means as we are writing this code on the same day, this thing is taking note of everything. Whatever we use, if we have used it before, it will use it as in recognize it. Is that what Python is doing?
100% correct. That's exactly how it works. So everything we've been doing since morning, it is storing it. It is storing everything in a memory. So now, for us to be able to see that it is actually storing it in true value, one way we can see that is when we come to our value here. You see that the file size here is what? It's 12 KB now. Are we together?
Yeah.
The first time we created the note like this file, what was if you look at it, the file size was just 1 KB, just one small file with small size. But everything we've been doing so far, all of the memories, all of the variables we are storing, they are consuming space. Shall we get it? So the space it is consuming is now what is inside Python, and that way it also makes it easier for us to call a variable. Now, the other time when I said I did not want to use X was because I've assigned X and I did not want to mix up the values inside X. Now, but the funny thing about variables and memory is that, here I use Y, Abby. If I
Yes.
come outside here now and I call Y, you will see what it will say. It gives me 4. Because here, the last stored value inside Y is what? Is 4.
4.
Shall we get it? Now, if I use X here, for instance, we see that X is 3. Now, if I had used X in this loop, if I had used X in this loop, everything I've done so far, previously X was 3. If I use X in this loop now, X will be 4. After I run this loop, and I come outside and I run X again, because the X is a variable on its own. So for every variable you are using, if the name exists before, it will override what is inside it. Are we together?
It will override the one that you used before.
Before, like the value that is inside that variable, it will override it. Shall we get
Please
it
go
now?
back to that. Go back to that. For X in range. No,
Yeah.
change it to X.
Okay, we should use X. Okay.
Use X. Now, what if the that in bracket we put 4
In
for X in range bracket inside bracket 4 instead of that 5 that we used before.
okay. Yes. Okay. Okay. Yeah, we'll go on break now.
Hello?
Once I explain this.
I'll
Yes.
quickly go on our break now.
Yes. Yes. I just want to explain this. Yes. Okay. Yeah. This would, at the end of the day, return 0, 1, 2, 3, and the last value,
Okay.
which is inside X, would be 3. Yes. But
And
I
so
just
my point is now, before we go for that break, my point is now, that's a crook. Let me just use crook way of doing things. Like
exactly. Yeah.
like I remember that we've already assigned 3 to X now, and I
Yeah.
know that if I use X and I put 5 there, it will still give me 4. But I quickly put 4. The thing will not be limited to 3.
Yeah.
So it will still be using
Hello,
the same
sir.
thing as before.
Yeah.
Hello, sir. Look at this. Oh, you have no more sharing. I want to show something. Okay, sir. Look at this in 80.
Hello?
Look at this.
Yes.
Look at this.
I
Look
think
at
we
this
can have
in
our
80,
break.
sir.
Yes, we
Let's
can.
have
Yes.
our break now.
No,
Yeah.
this is a question we might forget, and it's very useful for all of us. Hello, sir.
All right, I'm with you.
Okay, I said in 80. Look at this thing you wrote before loop. I thought you said that wherever you write this thing, that whatever you run will not affect that place.
Yes, it doesn't affect it.
I think now in the previous query we wrote, we
This-
put those things. So I think that 4, I mean that X should not still act for that X should not act for 4 as a variable. Since we have excluded that from our query.
Oh, so yeah, what I just wrote here is just a comment, and I said comments do not affect the code you write. Basically, and don't forget that we said Python is case sensitive. What I've written here is for capital letter F and capital letter W. These ones do not affect anything. It basically just runs the code and then nothing is happening here basically. So this line 8C is not doing anything. It's just there. Shall we get it? Yeah. All right. So we'll end here for now. We'll go for 10 minutes break. So by 1:18, we'll continue our class.
Okay, sir.
All right.
Congratulations. MG. Ṣùgbọ́n pé táwọn èèyàn bá sọ pé
Hero now, bossing his way. That's a good pass for Austin Banda, but just that touch that was needed, missed, picked up by Henry Versa. Mashimi Hero. The midfield for Kwazi is dead. Laps up.
All right, are we back?
Yes, sir.
Are we all on seats or some are sitting away? All right, so can we continue now?
I'm here already. I don't know about the rest people, sir.
Uh, I would appreciate that we know if they are here so that we don't have to like go back and forth.
I'm here, sir.
No, you're the only one here. The others are not here yet.
Okay.
Stand up. Stand up.
Hello, sir.
Yeah.
I think that video we are going to get you today because some of us cannot match up with you about the installation. The installation, I have not yet installed my Anaconda and Jupyter. So if I can get the video today, so I will be able to install before tomorrow class.
Okay, all right. I will try as much as possible to do that.
Okay, sir. Because by the time you are doing the installation, I cannot cope with doing the same thing and watching you doing it at the same time. So I have to abandon one for one so that I can see you do it.
All right.
Sir.
Yes.
Yes, my own side is actually for that mini Anaconda. And the way you explained, actually, I'm in a noise as at that time, so that's the reason why I couldn't follow up very well. But after clicking the folder, the file, I didn't see the local, the CD. He said I should click on CD, but it's not showing at all. Like it's not installing. I don't know. Maybe if we can do a Google Meet so that I can, because me, I'm not a tech something right from beginning. So this is more or less like a starter. So maybe so that it will be, let's say, online Google class, so that you'll be able to instruct me on what to do, so that I'll be able to install before tomorrow, and then I'll be able to practice some things that you've done today. Because I followed with the class, and also I understand a little about it. So I don't know.
All right. Yeah. So what we'll do is I think you can just message me on WhatsApp. We'll chat and then I can guide you through on what to do on it. You can chat on WhatsApp.
And also, this Jupyter notebook that you are using, will I be able to use it on that mini Anaconda?
Yes, you will be able to use it.
Okay, sir. Okay, sir. I'll do that once we are done. Thank you, sir.
All right. Okay, so let's continue with our class now. Let me know where you can see my screen.
Yes.
Yeah, we can see your screen.
Okay, all right. So.
Sorry, I still have a question. No, I don't know.
Yes, please.
Like I said, I joined very late. You're already on this Jupyter this thing, and I don't even know how to launch that. Maybe after the class or.
Okay, no problem. We'll do that.
Okay, thank you.
Okay, so now, this is the basic way of running. So let me just change this X to I or Y, any of them that I use. So now, so when I run this, okay, so this is. So I was explaining for loop, and then I've explained to us that range this is what is inside. So now, let's now assume that I want to. What we have here itself is literally what is inside 0 to 5, like what is here. But let's now assume that I want to use a for loop to print each of the letters of in the name Murtado. Are we together? So we know that Murtado name is Murtado, right? So when I come here and I say 4, and I say for, let's say, I in name, print I. What is this going to do for us? Now, what we expect or what we want to do is we want to print we want to print each character of the name what Montado that we have. So we expect that it should print you have each of them one line after the other. Are we together? So when we run this, we see now that it does so it sees MURTADHA. Now this easily prints out what we have here. Are we together? Now let's now say that we want to know the location of each of the each of the characters that we've printed. So this is location 0, location 1, location 2, like that till location 7. Are we together? How do we print that? Now, to print the index, because the location is called index. So to print each index and character, we would say for I in range of what? The length of name. Don't forget that the other time we talked about length of name to be what? To 8. So this means that this would go 8 times, right? And then we say that what? Print I, and then we say comma, print name of I. This would do what for us? This would print I in terms of location, because this is working in terms of the location. And now this is going to, let me just make this quite interesting and put dash this and take this. So this will show the location and the character in the location. So when we run this, we expect to have 0, M, 1, U, 2, R, and all of that. So when we run this now, we have something like this. So now this tells us that the letter M in the name Motado is in location 0. Letter U is in location 1. Letter R is in location 2. Letter T is in location 3, and all of that. Are we together?
Yes, sir.
No, please. Maybe you should re-explain, please.
Okay. So where is it from? This line 29 or line 29, 92 or 93?
I think line 92 is okay for me. It's very, very straightforward. But let's deal with 93.
So in line 93, what we want to do is we want to print each index. Index is the location of the character that we have, and the character of the name. So index is like location. Index is location basically. Now, what we now want to do is we say for I in now we want to know, for us to be able to get the location, we would use the number of characters that are inside the name, the variable that we want to use. Are we together? Now, the length that we now use, because this length would obviously be what? Be a number. We've confirmed this from our previous knowledge of length. This would give us a number. And from what we did for I in range 5, here we stated 5 as the range. It is a static number. But here, when we use length of name, it is a dynamic number, because the length can also change if we change the name. Sure, you get it. If we change the name, for instance, to Alakija is 7 characters, right? The length here would not be 8, it would be 7. And as such, we would have for I in range 7 instead of 8 that we have here. So now what we now did is, because we understand that each I that we have is a number holding the location of the name that we have, we say print I. I is what? I is a location. Now we now say that what? Comma. Now print the location in the name. So when we print location in the name here, we have done something here. We've done something called slicing here, but this is not completely slicing. This is just filtering of a character. So we just pick one character from inside. When we get to slicing, which is the next thing that we are going to talk about in NumPy in our next class by tomorrow, we'll be able to understand the idea of indexing and slicing much more better. But what we have done here with the for loop is basically indexing in terms of picking the index of a name of a character and the character itself inside a full name. Shall we get it? Are we together?
Yes, sir.
All right. So now, this is for loop. This is how for loop works. Now, if we now create a condition that is lesser than, for instance, we create a condition that is infinite, it would forever continue to run. The for loop will also continue to run and it will not stop. Do we get it? So in situations like that, what do? We need to use a condition that will stop. We must use a condition that will stop. And that way, the way to create conditions that will stop something is using a while loop. Now, for while loop, what it does is it continues to run until a condition is met. Until a condition is met. If the condition is not met, it will not stop. Do we get it? If the condition is not met, it would not stop. So now let's look at that, for instance. So let's say we have A is what? A is 5.5. Okay. Now, let's say that we say while, okay, before we use this, we say x equals to 0. Are we together? X equals to 0. Why x is less than A, print x. Print what? Print x. If I should run this code, who can tell me what will happen? Who can tell me what will happen?
That
if I run this code that I've highlighted, x equals to 0. You know that A is 5.5. Abi, from line 95, you can see that A is 5.5. Now, if I say while x is less than A, x is 0. While x is less than A, print x. Can you tell me what will happen?
That is, you print x before you should stop at 5.
No, that's not what is going to happen. I said that x is equals to 5, Abi. While is equals x equals to 0, sorry. And I say y equals to x 5.5. Then we now, you know that this while that we have here is a loop. Don't forget what will happen in a loop. A loop will continue to run. This while loop, it will continue to run until a condition is met. Abi now. Now, the condition we have set here is x is less than A. Is it true? Is x less than A?
Yes.
Yes. Now, if x is less than A, print x. What is
I think it will continue to print like 0, 1, 2, 3, 4, 5 and stop.
Okay, you said it will continue to print 0, 1,
Or everything that is less than A.
Everything that is
And then
less
stop.
than A. Okay. Now, but that is not the correct answer. Now, what will happen here if I should run this code is that it will continue to print 0, 0, 0, 0, 0, 0, 0, 0 for me till Jesus comes back. If I don't terminate this, do we get it? It will continue to run 0, 0, 0, 0, 0, 0.
Because
If
we
I
have
don't
already said that X is equal to 0.
exactly, because I've said x equals to 0, and I said here that what print x equals to 0 because x is equals to 0. X is 0 is less than 5.5. So let me
5.
show us what it's going to run. So when I run this, it will continue to run 0, 0. See, this thing is it will continue to run 0, 0, 0. It is not going to stop. Even if I drag this thing to the bottom, you see what is happening here? It would keep going. So let me terminate this. I have to terminate it. So when I scroll down, you see what it says. It says what? Keyboard interrupt, because I had to terminate it. It continue running 0, 0, 0, 0, 0. Because why? There is no condition to stop this 0 from making this condition false. Because this condition is what? Is true. And I said, once this condition is true, it will continue to do what? To carry out the operation. Now, what do we have to do to make this condition stop? And what do we have to do to make it print what you said that it should print 0, 1, 2, 3, 4, 5. And when it gets to 5, it should stop. The only way for us to do that is, so I'm going to go to the next page here, the next cell here, and I'm going to say x equals to 0 here, and then we say x is less than a because our a is 5.5. Then we say print x. Then we come here and say x equals to x plus 1. So what will happen here is that now the value of x would now change in this line. Are we together?
Yes.
Good. So the first line is x is equals to 0. Then it checks, is 0 less than 5.5? Yes, print x is going to print 0. Now x equals to x plus 1. So this now would change x to what? 0 plus 1. That is what? 1. So x now is now 1. So it goes again. X is less than a, which is 1 is less than 5.5. That is true. So it's going to print 1. Then it goes again. X equals to 1 plus 1. 1 plus 1 is what? 2. So x will change to 2. So it goes again. 2 is less than 5.5. So it keeps going till that condition is met. So it gets to the point where x is less than 5. So 5 is less than 5.5. Abi, it prints 5. Then it goes x equals to x5 plus 1. That is 6. Abi now, so is 6 less than 5.5? No. Then
No.
it is going to stop. So when I run this code now, let's see what it's going to do. So it's going to print 0, 1, 2, 3, 4, 5. Then it stops. Because what? The condition inside it when it got to 5 was what? 6 is less than 5.5. And that is what? That is false. That is not correct. Shall we get
You
it?
mean 6 is greater than 5.5?
Exactly. Because 6 is greater than 5.5, automatically the code would not run. The print function would not run. And everything under it. So it will stop. So when we look at for loop in terms of how it handles loop, how it handles iteration function, and we look at while they do the same thing, but for here now, they have to, a condition has to be met to stop this condition that makes it to work before it stops. But here, it will continue to run until it completes the condition that it has been set to complete. Do we understand now? So that way we are able to look at, okay, when do I use for loop? When do I use while loop? Are we together? Also, we can also use for loop and while loop in both cases. So we can use while loop even for to print MURTADHA. We can use while loop to do that also. So that is also something we can do. But we should not forget that we must set a condition that would stop the loop from running when it works. Now, we've looked at all of this now. The next thing we want to look at is we want to play around with some exercises. And we also want to talk about one more thing before we end our class. Please give me 1 minute, please.
Some action. Some action.
Yes, I'm here.
Good afternoon.
Good afternoon.
You were in class with that SQL, the last one that Mr. Edwin did.
Yeah.
Yeah, please, I will need your help. I'm in class on that day, but my battery, my system, so the battery, I was unable to continue with the class. So that's it. I don't know if you can help me out by teaching me or on what you did on that.
Okay, I will reach out to you on WhatsApp.
Okay, no problem. All right, thank you very much.
You're welcome.
All right, yeah, I'm back. Okay, so now we've explained for loop and while loop. Now there's something that we should also know. I don't know if I have talked about it. No, I haven't, and it is not here. But before we go on, we should also talk about let me change what is let me do it here. One more thing called arrays and lists. So let me just call lists. Now, what is a list and how does it work? A list is like it says, a list of items. It is a mutable list, something that you can change and you can perform operations on. So it's a set of items basically that are mutables. So why do we need lists? We need to know about lists because especially when we run or iterate through certain things, we should be able to we'll be using a list, and when we get to things like array in NumPy, these are basically lists in its form. Now, what is a list? So I can say if I have students, for instance, so I want to have a list of students. For me to create a list, I would use a square bracket. Are we together? A square bracket. Now, with this square bracket, I am able to assign things inside the list that I've created, and I'm also able to remove. Are we together? Now, I want to create a list of students, and these students will have a name. So I want to have name Ade. Now, each of them is separated by a comma. Are we together? Each of them is separated by a comma. So Ade, BC, Haro, Deji, Femi, and this and let me just say edits. So now these are students, right? So I have students here. Then I have I want to have their age. So okay, so let me call this student age. So this is 10, 13, 14, 12. How many students do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3. So we have 15 and 11.
Attention,
Yes.
sir.
Yes, I'm with you.
Student age. I can see that you put underscore. That means Python does not accept space.
Yes, it doesn't accept space as variable name, so they must be together.
Okay, is either I write it the student age together or I separate it with underscore.
Underscore. Yes, you can use. There are different variable style in that we can use. We can use something called the camel style. So where you have what's it called? The capital letter in between small letters. You can have capital letter for each of the beginning of the words. You can use anyone. You can even use small letter or two. So you get so. But I personally like to separate my words with what's it called, underscore generally. So
Thank you.
so now we have this now. We have so students and student age. Now, if I want to print each of the students, because if I say print, for instance, students, right, and I run it, it's just going to return a list of items that I have here. But I want to print each student, each name inside the students, what's it called? Inside the student list that we have. So how do I do that? What I would do is I would use a for loop and I say for, are we together? I say for, I can say students in students. Are we lost?
Continue, sir.
For students in students, I say print students. So when I run this, what would this do for us? This would automatically return each student inside students. Students is what? The list that we have. So this would print Ade one line, Ade one line, BC one line, Caro. Do we get it? Now, from here, we are able to see that if we have a list, we can print what's it called? We can print the items that are inside that list. Shay, are we together? We can print the items that are inside that list. Now, we can also print the first character of each of the lists, each of the items in the list. So now, you know, the other time we used what's it called? We used this square bracket to identify the first to identify the value of the location of I that we have here. So now let's now say that I want to say give me the first character of each of the student name. So let me come here now and copy this. So here I want to say print the first character of each student's name. So we have students in students. We now say print students. Now, by default, the first character of any value that we have starts from 0. So if you want to index it, like we said, we index it square bracket and we put 0. So when I run this now, this would return for each of the students that we have the value 0. The value 0, which is the first character in that name. So when I run this now, it gives me A, B, C, D, F, E, which is A is for Ade, B is for BC, C is for Carol. Now, for us to identify this better, if I do print this and I do comma and I say student. Now, when I run this, we see now that we have A, Ade, B, BC, C, Carol. It shows the name and the first character of that name. Do we get it?
Sir,
So,
yes, sir. Is it possible to print the age of the student across their name?
aha, yes. So, yes, we can also do that. And that's what the next thing we want to do, because we would also want to use
Please
a
go back a bit.
where should I go back to, please?
When what the code you wrote, that it only printed out the what's it, this thing, only the first letter.
Okay. So yeah, I removed this. So when I run this now, so this is the code that prints the first letter, which is the student's name itself, and returning the first character of that name.
Okay.
Yeah. So now, so we now say that I now use comma and I say student. So when I run this now, it shows the first character of the student's name and the name, the real name, the actual name. Now, if I want to print the first character and the last character of a student's name, are we together? Print the
Yes.
first and last character of a student name. Now, you see that all of these students, their first name they don't have the same number of characters in their name. This one has 4 characters. This has 5. Okay, everybody have 4 except Ade. So now, but how do we do it such that we are able to pick the actual last character of each of the student names? So I'm going to leave this part, which is the first character. I'm going to leave the student name so that we're able to see it. And so I will separate it with comma again, and I say student, and I use a square bracket and say -1. Are we together? -1. What -1 does is it starts from the back, the last character, and return the last character, which is -1. So when we do this, we should see for Ade, A, Ade, and E, B, BC, and I, C, Carol, and O, things like that. So when we run this now, so we see here we have A, Ade, and E. So now this basically tells us that we can pick any character from a string of names at any point. We get it. Now, let's now join students and their age together. We want to pick a student and the student's age. Are we there? How do we do
Yes,
this?
sir.
Now, how do we do this? Now, if we look at it, let me make it quite visible for us. If we have students, we want students, we have students. We have a list of student names. If we have student age, we have a list of age. Now we want to say Ade is 10, BC is 13, Carol is 14, Deji is 12, Femi is 14, Edet is 10. How do we do that? Now, we say for, are we together? For I in length of what? Length of students. Oh, sorry, for I in range, because it's a range, length of students, right? Then we say that what? We say print what? Number one, we want to print the student's name. So that's students I, because this is showing us the location of students inside. This is starting from 0 with this. Then we say that comma students age and I. Now, this way, let me make this quite interesting and say is, or no, let me put let me use this just to show that Ade 10 belongs to Ade and all of that. So now we expect that we want to see, what we expect to see now is Ade and 10, BC and 13 on the same line. Ade belongs to this and that. So now when we run this, we have Ade 10, BC 13, Caro 14, which is exactly what we have here. So this means that we can, with an index or the location that we have, assign certain values to another value inside another list. So we can connect two lists together. Are we together?
Yes.
Yes, we can connect two lists together. Now, we've been able to see what we can do with a list, especially lists that are with
Hello, sir.
Yeah.
Hello, sir. I want you to do something, sir. This last in range, length, students, print student, in bracket, square bracket, I want you to explain this code to us. This code, the
Line
meaning of this
110.
code, so that.
Okay. So, what line 110 is doing is,
Line 110, yes.
what line 110 is doing is, it is creating a number, a location number, right? And it is using a range from the list of students that we have. Don't forget that we said for us to know the number of items inside a sorry, I'm coming to something.
The length of the character.
Yeah, I'm with you. I'm back. So as I said, so the length is going to show us the number of items inside the variable that we have. Either it is a list or any variable basically. It's going to show us the number of items inside. Now, the number of items inside is, for this is 6. So it goes for I in range 6 because that is what it will automatically interpret it as. And then we say for each of these, print the number that you have, which is I. So students, if you start from 0, so it goes student 0. For us to understand this better, so when we do student 0, it's going to return Ade, student 1, BC, student 2, Taro. So it's going to keep going like that. Now, once it prints this, the next thing we want it to do is it should go to student age, this student age list, and do the same thing. Return student age of where you have 0 and 1. So when you do student age 0, it gives you 10. You do student age 2, it gives you 14. So you see, student age 2 years is 14. Student 2 years is 14. Student age 2 years. Student 2 years, Gabo. Student age 2 years is 14, which is exactly what we have here. So this loop, what it does is it goes to this before loop goes to the table until it gets to the end of the length, and then it prints everything that is inside the two tables. Do you understand it now?
Yes, sir.
All right. So I think, yeah, lastly is I wanted to show us something. I'm coming, please. So yeah, another thing I wanted to show us is the operators that we can perform with a list, because unlike every other thing, for instance, unlike every other thing, a list is different in terms of its structure because it has multiple items inside. This is a string, a string, a string. Now, a list has multiple strings in it. Same thing for these numbers that we have here. So, for instance, if I say 2 times students, what is going to happen? I say 2 times student and I run it. It basically multiplies or repeats everything inside students, this table, and then repeat it all over again.
Like duplicating it.
Duplicating it, yes, thank you. Now, if I say 2 plus students, it says what? Unsupported operator type plus integer and list. So it means that we cannot add an integer and list together. But we can do what? We can multiply an integer and a list. Are we together?
Yes.
Yes. So now, if we say, for instance, students start 2, what does it say? It says what? Unsupported operand type lists. So we want to do power of what? Of integer. See that this does not work. So here now we are able to see that what is inside the list defines the kind of operator that we can use with it. So let's go to student age and see something quite different. So 2 star student age. So when I run this, what does it do? It duplicates the ages that are inside 2 times. Now let's come to say 2 plus student age. So when we run this, it says what? Unsupported operand. Let me do something. And plus 2. Now it says can only concatenate list, not integer. So now this list is saying 2 as what? As an integer. and it says it can only concatenate this with another list. Why? Because what is inside student age to us is a number. So we expect that we should be able to perform an arithmetic operation, just add 2 to all of the numbers that are inside. But in fact, that is not it. We get it. So same thing occurs when we do things like this. Okay, this okay, we've done this. Star. Same thing occurs when we do things like this, raised to power. So now, how do we then alter what is inside this list? How do we alter what is inside, let's say, student age? And let's say we want to add 2 to their ages. So we want to do student age, for instance. We want to say, oops, sorry. We want to say this 10, we want to convert this to 12, we want to convert this to 15, convert this to 16. How do we do that? Now, the way to do that is 2 ways. We can create a new list. Create a new list. So we see the name I've used, students underscore age, and we say equals to a list. Right now we said student age is what? A list. Then we say for I in student age, okay, and for I in student age, because it is number that is inside, students underscore age dot append. Are we together? I plus 2. What is this going to do for us? So at the end, let me now say student age. Now, what I've said here is I've created a list, an empty list, right? And I say for I in student age, so this is one I, another I, another I, another I. So I say what? Student's age dot append. This list that I've created, this empty list, append whatever is here, which is I plus 2, inside this empty list. So keep appending it till you get to the end. And when you are done, print this empty list for me. So let me see what is inside this empty list. Or let me even make it easier for us to understand better. So let me cut this. Let me insert above and run this. So when I run this, it has created, right? To show us that what we have created is empty. So when I call student's age now, there is nothing inside. Abi now. So we can see that there's nothing inside student age now. So let's now run this. Let me remove this also so that we don't feel it as. So now when I run this part for I and this, now it has run. So let me go to student age now and see what is inside. So we see now that we have 12, 15, 16, 14, 16, 12 inside student age. Earlier, student age was empty, but what we have here, dot append, is a function that adds items inside student list. Are we together?
Yes, sir.
All right. So also, if we want to remove an item from a list, we use a function called dot pop. And this dot pop, it doesn't take anything. It can actually take an argument, but it takes the last item off. So it takes, so we can see here it says index -1. Although we can set what we want to remove also, but index -1 means that it removes the last item. So when I run this, it's going to remove 12, and it will give us 12, 15, 16, 14, 16. So that's removed 12. So when I run this now, you can see now that we have 12, 15, 16, 14, 16. So we'll stop here for today. I would want us to practice what we've done. So I'll share this file with us. I'll share this file with us so that we are able to practice it on our own. Do we get? We are able to practice it on our own, and so I'll share this file with us on the group so we're able to practice it on our own. We can go through it and try to re-implement what we have done here. So we'll stop here for today, and we'll continue tomorrow by God's grace. Any questions?
Hello, sir. Please, sir. Please, sir.
Yeah.
Yeah, like I said, I didn't join from the beginning. The class has already like an hour before I joined. How do I launch the Jupyter this thing so that I'll be able to practice?
Okay. Do you have Anaconda Navigator installed on your system?
Yes.
Okay, good. So when you open Anaconda Navigator, you have something like this. Am I right? So go to your search bar here, your Windows button. You can just type Anaconda, and then it's going to show all of the Anacondas you have. Just open Anaconda Navigator.
Okay.
So when you open it, after it has opened, then you can come to Jupyter Notebook and then click on Launch.
Okay.
So when you click on Launch, it is going to bring you to an environment like this, something like this, where you have everything on your system, your desktop, your documents, your downloads, your all of them, everything on your C drive is going to show you. Then you can then go to you can just click on your desktop and come to New, click Create Folder. So you want to create a new folder. Are you together? Create a new folder.
Please, sorry. I'm trying to follow you, but I think I'm having an issue.
You know what? I think what I would do is I would try to send like a step-by-step process, like the text to the group after this call, so that we are able to can catch up with that. Or another thing.
Okay, but continue. I think.
Okay, so
continue.
once you create a new folder,
I'll click on desktop, then I click on new.
Yes, click on new and you click on folder. So when you click on new folder, you would see it's going to create an untitled folder.
Okay.
So you can click on this. You can click on this checkbox beside it.
Okay.
And then go up and click on rename.
Okay.
Then you can call it data analysis. I've forgotten what we called our own. So you can call it Python for data analysis class.
Okay.
So once you've created it, click on it, and inside this Python for data analysis class, you can then click new and click Python 3.
Okay.
So once you do that, it will bring you to a new environment. Let me just show you. It's going to bring you to a new environment like this. Now, let me just also tell every one of us that for Jupyter Notebook to run, it's not compulsory your internet is on. So it works without your internet, so that we don't have to bother ourselves. So yes, so it's going to open a new a Python 3 file like this for you, and you can click on this untitled and you can rename your files. You can rename your file based on whatever you want. So when you rename this, now it sees, it tells you file already exists. If a file already
Okay.
exists and that bears the name of what you have, it's going to tell you. So then you can so this is this. So I don't need this.
Okay. So, but you still help us drop the step-by-step this thing on the top.
Yeah. So I'm going to send
Hello,
this.
sir. Hello, sir. Before you go, kindly send to us too how to run that Panda Seaborn Matpoli that we downloaded. How to run it? You said we should run it.
Okay. Yes. So when you come to your Anaconda prompt, this is Anaconda prompt, right? So once you click on Anaconda prompt on your Anaconda Navigator, also this is it here. This prompt here, this is it. So when you click on your prompt, it's going to basically open, and then it's going to, you can then use, all you just need to do is write pip install and the package name or the library name you want to install, numpy. Once you run it, if you have it installed on your system before, it's going to tell you requirement satisfied already. Requirement already satisfied. That is what you would have if it is installed on your system already. But if it is not installed on your system already, it is going to install. Now, this requires internet to install. Do we get it? This requires internet to install. So you can also do that for the remaining one. Pip install plotly or pip install matplotlib. All of the packages that I've listed for us. So once you do that, if it is installed on your system before, it will tell you package already requirement already satisfied. So these are basically what you have to do when you want to use the Anaconda prompt.
How do we run it?
You just press enter when you are done writing it on your system. Just press enter. Like after typing, just tap enter. Enter on your keyboard. Just press it, enter. So once you are done typing, just tap enter. That's all. Do you understand now?
Okay, sir.
All right. So this is where we'll stop for today. And I think, let me see. I'll share also this file, and then I would try to get the video on how to somebody requested for video on how to install something. I can't remember the thing again. Please just ask out.
It's all these things you have shown us.
Oh, okay. Oh, so I already showed you. No problem. So there, this easy to do. All right. So we'll stop here for